All right, time is 7 o'clock. So, very good evening to everyone. Our source person, Dr. Jitesh Pradhan sir, has already joined, and I'd like to hand over the session to Dr. Pradhan sir to continue the session. Thank you so much.
Okay. Uh, am I audible?
Yes, sir.
Okay. Thank you so much. Okay, just a second. I am sharing my screen so that we can start with the presentation. Okay, so my screen is visible.
Yes, sir.
Okay. So basically today we will start with the NLP, and if we will be having a sufficient time at last, then the two topics were left in yesterday class. One is bidirectional RNN and another is LSTM that we will see. Okay. Although I have already covered the basics of RNN. Now, just a second. So basically in today's this presentation, we are going to discuss about the introduction to NLP. At the same time, we will be also discussing the AI project lifecycle, how AI project will initiate and it will be deployed from its starting to ending point. Okay. Now, these are the outline of my presentation. I will be covering introduction to the language. Then we will see introduction to NLP, history of some NLP techniques, then some NLP ambiguities. Then we will see learning approaches of NLP, core components of NLP, how features have been extracted in NLP that we will see. Then we will discuss some NLP case studies. Then we will go for AI project lifecycle, followed by application of NLP and NLP models. So these are the topics that I have planned to cover in today's this session. Now, let's start with the basic definition of a language. So we all know that, na? Okay, what is a language? Basically, language is nothing but it's a structured way to communicate between humans. Okay, and as per the Oxford Dictionary, the definition of language is a principal method of human communication consisting of words used in a structured and conventional way and conveyed by three things. Either it can be conveyed by speech, writing, or gesture. Okay, for example, is a study of the way children learns a language. So it's a basic definition of a language. So in language, we used to convey it through three things. One is speech, second one is writing, and third one is a gesture. Okay, in NLP, these two, speech and writing, will be handled. Speech and writing is an example of text. Okay, so basically it will be NLP in text will be a portion, and speech is basically it's a speech. Okay, speech directly we can analyze the speech, so that it's basically whatever I am saying, that conversion of that my voice to a text. Okay, that falls under this speech category. Okay, another definition is language is just a system of communication used by a particular country or a community. Okay, these are common definition of language. So features of languages, it should be structured and rule-based communication, because whatever language we are following, there will be some rules. There will be some grammars, there will be some semantic structure of the grammar, so that it convey a specific or valid meaning. Okay, it uses symbol, words, and grammars. It can be expressed through speech, writing, and gesture. So these are just a basic definition of a language. Okay, now properties of human languages. There are 6 basic properties of human language. First one is a displacement. So what is a displacement? Now this word displacement, we know, na? Displacement is moving something to another place, and it gives you the smallest distance. That is called displacement. Now in case of human language, the displacement is, we can talk about past, future, and current scenario. Okay, so we can discuss, or we can write or describe our language in terms of a tense. Okay, so ability to talk about past, future, or distinct things. Okay, this is called displacement. Now arbitrariness. So there is a no relation between the words that has words and its meaning. For example, whatever words available in our dictionary, there will be no particular meaning if a word is present in English and then that same word is present in, let's say, Hindi. For example, if we are saying water, so in English it's a water, but in Hindi it is a pani, and in Bengali we can say jol or something like that. Okay, so there is arbitrariness. Okay, now Another one is a productivity and creativity. Now what is the productivity, creativity? Now there is a no limit to create sentences, because we have word, we have vocabulary, we have rules and regulation, we know how to create sentences, and thus we can create infinite sentences. Now let's take a common example. AI will change education. Now why this is a creative sentence? Now let us assume that we are in 1950s, and suppose I will say that AI will change the education. Now in 1950 nobody was known to the AI term. The AI term has been coined in 1958. So till 1958, the AI term was not present. No, okay, but I can create an artificial word was there, intelligence word was there. So artificial intelligence we can create, and we can write IT. We can say that AI will change the education. Now this term, this sentence has been curated at that time. So it will be that will be the new sentence for 1950. Now another thing is a cultural transmission. Okay, so language is learned from the society and family. Whatever language we are using, our mother tongue, okay, our mother language, we will learn it by our house, or from our ancestor, or from our society. Okay, so it's a basically a property of a language. Now there is two more, that is discreteness and duality. So first, what is a discreteness? Discreteness is a basically the language what we are saying, or words what we are saying, it has been made up of separate sounds. Okay, let's say for example bat. And bat and cat, these two are not same. Why? Because bat, we can say it, uh, these are example where bat is, it's giving another sound. Okay, it is another sound that has been generated from our vocal cords. The cat is another sound. So discrete language is made up of separate distinct sounds. Okay, that is called discreteness. And duality is a duality, basically meaningful words that are formed from a meaningful sounds. For example, a word we have to found, then we have to create different what we call it, vocal cord sounds. For example, if we are saying bat, then it has been made up of a B-A-T. B we will call B, A it is called A, and T it is called T. There is three different sounds that has been generated from a vocal cord. But while I am saying bat, then this bat is different from B-A-T. Okay, it is called duality. Now, so basically these are 6 properties that human language follows. Okay, now let's come with the linguistic. So what is a basically linguistic? So linguistic is basically uh, in NLP, linguistic help the computer to understand, interpret, and generate human language. So linguistic is nothing but it's a scientific study of language and its rules, structure, and usage. So why the scientific study will be done? Because we are talking about NLP now. So it gives us power so that a computer can understand our human language, it can interpret it, or it can generate human language. From it can convert one human language to another human language. That is the definition of a linguistic. So basically it is study about sounds, it is study about words, grammars, meaning, sentence, and its formation. Okay, it is study about all these things. Now we have 2 types of linguistic. One is called descriptive linguistic. Another one is our prescriptive linguistic. So now what is a descriptive descriptive linguistic? In this case, descriptive linguistic are actually used by people. These are actual use case. Okay, now for example, the language that has been described by the people and they are actually using it. For example, people say I aren't going. Okay, so in this case the focus is observing the real language use. What? Because I are not going, as for I aren't going, maybe the sentence will be wrong, there is a chance, but people are using it. Okay, people may use some phrases that might be not grammatically correct, but the focus is the real use of the language only. Now when we talk about the prospective linguistic, so prospective linguistic focuses on the grammar rule. Okay, it restricts to the grammar rule. Okay, so what is correct or incorrect, it will be discussed in the prospective linguistic. For example, now let's say I didn't see nobody. Okay, it's an incorrect use, because I did not see nobody, it won't happen, because the correct use is I did not see anybody. Okay, so when we are dealing with this grammar based thing, okay, where we have to stick to the grammar, then it is called prescriptive in linguistic. And when we are going or dealing with the daily use language, okay, where what people are regularly using, then this is basically your descriptive linguistic. Okay, so basically in NLP, linguistic helps the machine to understand how words are formed, okay, how sentences are structured, what meaning words convey, because words often convey meaning based on their context. One common example I can say, the bank word. Let us say bank word. If the bank word can be used to store money, na, bank stores money. At the same time, bank can be used to represent the bank of a river. Now, if we are using that bank word with its context to river, then it will be bank of river, and with respect to the money, then it will be a bank storing money. Okay, so word often shows different meaning based on their context. Okay, so we need to understand how context changes the meaning also. All these are part of linguistic. Okay, now let's say a common example. Let's say if I'm going to the bank in this case, na, so bank can be uh, SBI bank, HDFC bank, or anything bank. At the same time, it can be the river bank also. Okay, this is the main thing. Okay, now in linguistic we do separate operation. We will see it later. Now let's move to the NLP. Now, what is basically our NLP is? So basic definition of NLP is one of the, it's a research area in the computer science, where NLP is a branch of computer science which mixes three things: computer science, artificial intelligence, and probability based linguistic. So basically NLP is nothing but it's a language. It can be text or it can be sound. Okay, we are now dealing with sound also in NLP. Originally it was for the text. So okay, so NLP is nothing but it's a language plus computation. Now, due to the progress with the machine learning, the linguistic has been changed. Okay, now this NLP has been changed. Now it's not language plus computation. It's now linguistic plus probability. Now linguistic means whatever the fourth that we see now, how words has been formed, how what words conveying meaning, whether the words are correct or not. So these were linguistic. Okay, we will do separate so many operation with linguistic. Okay, we will discuss this later. Plus probability. Okay, so probability is nothing but it's a machine learning. It will basically classify something into some category, or it will try to predict the next word, or it will try to find the sentiment. So these two are now the current trend in the NLP. Okay, so what NLP does, it helps human to process the text and speech both. In NLP we can process both textual information also we can process, or speech information we can process. Speech information, by we can process speech information via two things. First, directly we can process, we can take speech as our signal form, and we can process it by finding features, or another, we can generate text from a speech and we can process it. At the same time, it can relate to the computational linguistic. Okay, it can use computational method to analyze human language. Okay, it basically bridges gap between human and computer. Okay, so why bridges the gap between human and computer? So that we can interact with computer in our own language. Okay, because computer doesn't understand any language in terms of, if it's a high level language, whether it's a English, Hindi, Bangla, Arabic, or it is like Spanish. Computer doesn't understand. Computer understand only binary code. Okay, now this NLP is a way to interact with computer, or so that computer can understand our own language. Okay, what are the application of NLP? Chatbots, virtual assistants, machine translation, speech recognition, sentiment analysis, text summarization. These are common applications are NLP. Okay, now in sentiment analysis also we use NLP. So in sentiment analysis we try to predict the sentiment from text or a speech. Okay, somebody writes some tweet, or some, let's say if someone is writing some post in Twitter or in Facebook, we can analyze that tweet. Okay, and we can try to find the sentiment in that tweet. It can be a positive sentiment, it can be a neutral sentiment, it can be a negative sentiment. Positive sentiment can be happiness, it can be basically satisfaction, it can be a neutral sentiment, means people are normally posting, there is no intention behind that. Okay, and negative, the person who is posting the tweet, maybe he will be sad, he will be in depression, he will be in angry. So these are the negative sentiments that we can predict. Okay, at the same time, now we can, in sentiment analysis, so common example are, we can predict the sentiment from text or a speech. Okay, somebody writes some post in Twitter or in Facebook, we can analyze that tweet. Okay, and we can try to find the sentiment in that sentiment. Positive sentiment can be happiness, it can be neutral sentiment, it can be a negative sentiment. spam or ham detection. Sorry, common examples are that depression detection from the tweet. Okay, cyberbullying from the tweet. Okay, now toxicity classification from the tweet. Okay, these are some common example in sentiment analysis we do. Okay, now at the same time, other application of NLP are like ham or spam classification, where we are email is there na. So whether the email is a spam or it's a ham, it will classify based on the content of email. Okay, at the same time, right now, even in call also we can Airtel right now publishing na that all the calls has been integrated with AI, that Airtel uses AI to predict whether or to identify whether call are ham or spam. Okay, whether the calls are legitimate or these are spam calls. Okay, so right now AI has been using, everyone is using AI. Okay, so in text summarization also we do the, for common example of text summarization is we will feed the entire paragraph and we will try to find the core summary within 1 or 2 lines. That's it, the text summarization. Okay, or another right now people are using text summarization is from a speech. Somebody is giving a speech, then summarize the speech in very concise way. That is another example of text summarization. With the text summarization, there are some other applications also. Solving MCQ from a text. Okay, we will be feeding some text information to our NLP system. NLP system learn that text, and from that it will solve MCQ or short question answer. Okay, these are common examples or applications of NLP. Okay, now NLP based product we are right now. Google Translator is completely NLP based product. There we can translate our text information from one language to another language. We have ChatGPT. Okay, so ChatGPT is basically it's a LLM model. Okay, where we can literally interact with AI in terms of our own language. Now we have a Siri, we have Alexa. So these are basically common examples of common applications of NLP. Okay, up to this point it is, I think, clear. If you are having any doubt, you can ask me. Okay, now let's basically dive into the history of NLP. So it has been started from 1950s. Okay, and major development is in 1950, Claude Shannon and Noam Chomsky introduced the language model or basic grammar theory. So what is a language model and grammar theory? Because in 1950s, the Turing machine was invented. Okay, then from the Turing machine, that's why the Chomsky hierarchy comes into the picture. So all of you must know, no, what is the Chomsky. If you are from the CSE background, then you must know what is the Chomsky hierarchy. Entire language has been divided into 4 classes: regular language, context-free language, context-sensitive language, and unrestricted language, where the Chomsky, very Alan Turing proposed a very well-known hypothesis that all the real-world problem can be modeled in some way that will involve Turing machine in its solution. It means, in direct way, we can say that all the real-world problems can be solvable through the Turing machine. That language model and the grammar theory comes in 1950. This grammar theory is basically base of every NLP, because in NLP processing we will do everything. We will do tokenization, we will do syntax analysis, we will do semantic analysis, and thereafter. So all these are part of compiler design, okay, where this grammar theories has been used. Now, in 1960, early AI systems like ELIJA and question answering system was developed. When then 1970s, NLP understanding, that is natural language understanding, and this Markov model based speech recognition system was introduced. Then in 1980s, statistical method used for parsing and POS tagging. Here, POS tagging is basically, it's a part of speech tagging, and parsing is basically parsing of words from sentence or sentence from words. It is basically, there are 2 types of parsing. One is known as top-down parsing, and the other one is known as bottom-up parsing. So in top-down parsing, what we do, from sentence we parse it to a word level or character level, and in reverse, in bottom up, from character level we to try to form the sentence. That is called parsing. Okay, and POS tagging is basically part of speech tagging. So we will be having a speech, or we will be having a sentences. We will divide the sentence into a smaller part, and each part we will try to tag it with its meaningful information. For example, if whether the part of that speech is a noun, pronoun, it's adjective, or it's a any other thing. So that is the POS tagging. Okay, so this parsing and POS tagging was introduced in 1980s. Okay, now in 1990s, Okay, rise of machine learning was there, and statistical machine learning translation was started. Okay, where we literally started the machine translation. Now in 2000 we use SVM, okay, CRF, information retrieval and semantic analysis things. Okay, now in 2010, okay, deep learning and neural network based NLP system started, where we used a transformer and everything. Now in 20s, okay, we are using large language model like GPT model or generative AI models. So this is the history of NLP, where we started with the basic Chomsky hierarchy or grammar theory, and right now we are literally using generative AI and GPT. Okay, so basically these versions were rule based system, because it will convert a grammar to another grammar. Okay, so these were rule based system. Then we come up with a statistical NLP, then machine learning based NLP started, then deep learning based NLP started in 2010, and then generative AI started. So basically this rule based system is up to this 1970s. Then in 1980, it is basically statistical NLP. In 1990, it is machine learning LLP. In 1990s and 2000s, okay. In 2010, deep learning based NLP started, and in 2020s, after generative AI based, this NLP started. Okay. Now, what is a basically language topology? So I think you know now what is a language topology. Language topology. So word topology is basically a structure. Okay, and language topology basically deals with the structure. How a language or its word will be structured to form a sentence. Okay, based on that topology, we try to classify the language into different categories, whether it's a Sanskrit language, Latin language, or something else. Okay, that is the basically language topology. Now in this case, let's say it's a three. Okay, it has been written three. Okay, but the meaning is, its meaning is three. In Sanskrit we write it trias. In Latin we say it tres. Okay, these are common. Basically these are uh, structural difference na. These three are showing same thing na. It is basically representing three. In counting, it will be 1 2 3. It will be three thing, it will be anything. Okay, now in meaning, in English we will write it three. In Sanskrit we will write it tryas, trias. Okay, in Latin we write it tres. These three are having different structure. Okay, but the meaning of these three are very simple. Oh, very same. Okay. Now, in simple ways, if we can say what is the language topology is, so language topology groups the language according to how they are structured and used. Okay, it will start from character to it will go to the paragraph. Okay, so basically it compares. It will basically we have different languages, na? So it basically compares similarity, differences, and common patterns between the languages. So that is called language topology. For example, let's say in let's take a sentence. Let's say if say I eat apples. Okay. Now in different languages, the order will be different. Its structure will be entirely different. For example, if we are saying it in English, so I will say I ate apple. So so sentence formation will be like subject plus verb plus object. Okay, because I ate apples. Now in Hindi, if we say, I will say मैं सेब खाता हूँ. Now मैं सेब खाता हूँ, that object सेब is now coming in the front side. In English, it was coming at last. Okay, so this is the basically topology. Okay, language topology, how sentence will be arranged. Okay, although the sentence will be conveying same meaning, I ate apple and मैं सेब खाता हूँ, both are saying same thing, but the arrangement of the words, their structure is completely different, and that is language topology. It will be dependent on the language rules. In the same case, seven will be written as a sapta. At the same time, in Latin, it will be written as septem. Okay, so king, in English we write king, in Hindi we write raja, and in Latin we write regem. So these are common examples of the topologies. Okay, so up to this point it is clear. Okay, up to this point it is clear. Now, if you try to understand the topology, then there is one more thing. Let's say if we are trying English, now always it follows the pattern: subject, verb, then object. Okay, when we are writing in Hindi, it uses subject, object plus verb, and when we write in Arabic, it will follows the verb, subject, object. Okay, so basically this language topology can be divided into three words: S, V, O. S means subject, V means verb, O means object. So English follows SVO, that is subject, verb, object. Hindi follows, or Hindi or Japanese like language follows SOV, that is subject, object, verb. Okay, and our Arabic like languages follow like VSO, that is verb, subject, and object. So that is the language topology, how the words will be structured to form the sentence, although they will convey the same meaning. Okay, now, so let's discuss about the major Indian languages that we deals with. Okay, now why we are discussing this? Because NLP is having everywhere. Now we are applying NLP in all these languages. Some of these languages are high resource language, some of these languages are mid resource language, and some of these languages are low resource language. So languages, we are right now, I'm talking about the Indian languages only. Okay, so language has been divided into the three categories based on their corpus. So what is the corpus we need to understand, because corpus will be used everywhere. So corpus is a collection of your data in which you are going to train your model. So corpus is your basically training sample, you can say. Now high resource language will be having high corpus. So corpus will be everywhere. Okay, so a common example is English, Hindi, okay, Spanish. So these are very common languages. Okay, so their corpus are very high. You can find English sentences, you can find Hindi sentences, and even you can even find their mapping also. So these are called corpus. Okay, and these are high corpus based system or high corpus based languages. That's why we call it a high resource language. Now here comes mid resource language. So mid resource language in which the corpus is somehow limited. It is not widely available, but it is available in sufficient quantity so that you can perform your what you says NLP task. Now that Dravidian languages, for example, Telugu, Tamil, these two are mid resource language. Okay, apart from this, let's say your this some Kannada and Malayalam is also there. Urdu language is also mid resource language, because Urdu we have enough text, but its conversion to English from the Urdu text, it is somehow resource limited. Okay, so these are called mid resource language. Okay, and the low resource language, which is a very hot topic right now, everybody try to work on a low resource language, are the languages in which the resource constraint is there, corpus constraint is there. We don't have enough corpus. The common example, we are right now in this I am right now in Jharkhand. Okay, now in Jharkhand there is a Santhali language, na, and it is extremely low resource language. Same case, Bodo and Manipuri. These two are also very, very, very low resource language. If you are doing some work in this case, then that will be a phenomenal job. So basically, we have four categories of languages in our India. One is Indo-Aryan, another is Dravidian, another one is Austro-Asiatic, and then Tibeto-Burman. In Indo-Aryan, we have Western, Southern, and Eastern. That is Magdi, Maharashtri, and Sausarani. Where in Western, it comes Punjabi, Gujarati, or Hindu-Urdu mix. That is Western Hindi. So this comes under Western Indo-Aryan languages. Then we have Southern Indo-Aryan languages in which Marathi and Konkani comes. Okay, and in Eastern, we have Eastern Hindi, we have Assami, and we have Bengali. Okay, at the same time, when we are going to south side, we have Dravidian languages, South Central Dravidian and South Dravidian. Okay, in South Central Dravidian, Telugu comes, and in South Dravidian, Kannada, Tamil, and Malayalam comes. Okay, at the same time, we have Austro-Asiatic, where Kasi and Munda language is there. We have Tibeto-Burman languages, the Bodo and Manipuri is there. So these are common classification of language hierarchy in our India that we are right now working. Okay, now let's take some interesting cases where this, why NLP is a complex. These are some interesting cases because there is a NLP ambiguity. Okay, now let's take the word order in different languages. In English, we wrote, I know the boy who lives in a Berlin. We have written. So look at here. It has been written like the structure is subject is first. Okay, verb is second, and object is at last. So this is the formation of a sentence: subject, verb, object. Okay, now same case in German, we write it like this. Okay, I can't spell German. Okay, so observation in this case is that the main verb that is left, okay, appears at the end of the clause. Look at here. In this sentence, the main verb that is left, it is appearing at the last. But in case of this English language, the verb was appearing in the middle itself. Okay, so the structure has been changed. Okay, now German word order changes depending upon the sentence structure. Okay, so these two are same thing. Okay, the meaning of this German sentence is the same. I know the boy who lives in Berlin. Now let's do it in Hindi. So मैं उस लड़के को जानता हूँ जो बर्लिन में रहता है, और एट द सेम टाइम वी कैन राइट इट लाइक दिस ऑल्सो, मैं उस लड़के को जो बर्लिन में रहता है जानता हूँ. Hindi is more ambiguous. Okay, because look at here, in these two, the observation is Hindi allow flexible word order. मैं उस लड़के को जानता हूँ जो बर्लिन में रहता है. At the same time, we can write it like this also. मैं उस लड़के को जो बर्लिन में रहता है जानता हूँ. Okay, so these two are same, conveying same meaning, but the arrangement of words has been changed. It means order of word can change, and with the change, these two structure may give the same meaning. That is the flexible word order of Hindi. That's why NLP in Hindi is very difficult. Okay, so different languages having different grammatical roots. So that's why creating a generalized NLP model is very difficult. Generalized NLP model will be like we are talking about a general AI based NLP system, which is not narrow. Okay, general AI based, it means that can handle multiple tasks, multiple at the same time in different languages. So that's why, because the grammar rules are very different in different languages, and their order may also change. That's why working in NLP is very difficult. Okay, now let's talk about NLP ambiguity, its stages with some examples. Now, what is the NLP ambiguity is basically? So in simple way, we can say that the definition of NLP ambiguity will be ambiguity occurs when a word or a phrase or a sentence has more than one possible meaning. Now, if you are from, all of you are from CSE background, you must have heard, must have studied TOC or compiler design. Na? And there is an ambiguity in grammar. So we use context-free grammar, where it's a basically second level of grammar, where we try to find some sentences and we try to parse them or try to generate a parse tree from them, and the same grammar can generate multiple parse tree for a given sentence. That is called ambiguous. So it means a single word or sentence may convey multiple meanings. That is called ambiguity. So NLP has ambiguity, and to deal the ambiguity, it is very difficult. Okay, so simply ambiguity is basically nothing but it's a having multiple possible meanings of a single word. How? Okay, same words can convey multiple information based on their what we call it, its context where we are using that word. Okay, same word may give you different meanings. Okay, so a single phrase, it can be there, it can be a sentence, all this can give you multiple meaning. So sentences are often ambiguous. So that's why working in NLP is very difficult. Now let's take another example. Okay, now let's take another example. Now let's say I saw a man with a telescope. Okay, now here the same, it is a single English sentence, grammatically very correct. Okay, because what I have said, I saw a man with a telescope. Now thus it is an English language. Okay, English sentence it is there, and it is a grammatically perfect. Okay, now what is the ambiguity in this case? Now it can convey multiple meaning. Now let us see. Now I saw a man with a telescope. It means I means myself, saw another person through a telescope. It can convey this meaning. Okay, that means I have used a telescope to see another man. Okay, at the same time, the meaning can be like this also. I saw a man with telescope. It means I, from my bare eyes, sees another man having telescope. So same English structure, same sentence with the same words, but meaning is entirely different. Okay, now the difference, this word's meaning may be context dependent. Okay, how context dependent? We need to analyze the sentence coming before it and coming after it to analyze the actual meaning. Which meaning will be accurate? I saw a man with a telescope, whether I used a telescope to see a man, or a man had a telescope and I saw him. Okay, these two meaning it will be context dependent. Okay, so that's why NLP is very difficult. So we have these type of we have basically these are stages of NLP where we initially I will discuss it in the next slide. Okay, the type of ambiguity is sound ambiguity, word formation ambiguity is there, word sense ambiguity is there, structural ambiguity is there, meaning ambiguity is there, context ambiguity is there, and reference ambiguity is there. So context ambiguity, just now what I have discussed. I saw a man with a telescope. Okay, so meaning will be I saw a man with a telescope. It means I have used a telescope to see a man, or I see a man which is having a telescope. That is a context ambiguity. This sentence is context dependent. Okay, it means we have to analyze its previous sentence and its after sentence to get the actual meaning of this. That is called context ambiguity. Okay, now the sound ambiguity is what? I scream versus I scream. Okay, because when we write it, okay, because it's a phonetics and phonology. Phonology deals with the voice. Okay, so when we pronounce, okay, I scream. So when I say I scream or I scream, so this is a what we are pronouncing. It may be written different, but our pronunciation or our vocal sound may appear same. So that is called phonetic or phonology based ambiguity, that is sound ambiguity. Okay, now in second, that is morphology. So morphology is basically, morphology deals with word formation and its structure. Okay, we will discuss morphology in very detail. Okay, so word formation ambiguity is there. So what is the word formation ambiguity is there? Look at here, unblockable, cannot be locked or able to unlock, sorry, unlockable. So it's a word formation. We can write it like cannot be locked also at the same time, or able to unlock. These two are there. It's a meaning of unlockable. Okay, unlockable is there. We can write it not be locked, cannot be locked, or we can write able to unlock. So these are word formation ambiguity, how we can form the words. Okay, at the same time, lexical analysis. In lexical analysis, we will see that is word sense ambiguity is there. Now, what is word sense ambiguity? How we are sensing the word. A word can have multiple meaning based on its context. Like a bank. I am going to a bank. Okay, it can be a river bank. It can be a money bank. Okay, so in lexical analysis, word possesses multiple meanings based on their context. Okay, in which context we are using that bank will be the meaning of that bank. For example, if simply I am saying I am going to a bank, it won't convey accurate meaning. We need to analyze the before sentence. Let's say I have a money, I am going to a bank. So it means I have a money, I am going to deposit that money into bank. It will convey. Now, at the same time, I am feeling very suffocating. I am going to a bank. It means I may be going to the river bank. Okay, so this is the word sense ambiguity is there. Now we have structural ambiguity is there. So structural ambiguity, just we saw. I saw a man with a telescope. That is also a structural ambiguity. Now the structure is correct, but the same structure can give you the multiple meaning. Okay, so structural ambiguity, it means the structure will be having multiple meanings or multiple interpretation. It is having a correct structure, but the same structure can give you multiple meanings. That is the structural ambiguity. Now we have this, another is meaning based ambiguity, or we can call it semantic ambiguity is also. Visiting relatives can be boring. Okay, now in this case, sentence meaning is very unclear. Visiting relatives can be boring. It can have two multiple meanings, like how visiting relatives can be boring. It means relatives are visiting your house and it's a very boring process. Or at the same time, it will be there that you are visiting to your relative house and that is a boring process. So it's a basically semantic ambiguity. Okay, or where the meaning is ambiguous. Okay, now we have context ambiguity. Okay, can you pass the salt? Okay, it's a question. Request, it's a with a question mark. Now here the context, it is context dependent. It's a request, not question. Can you pass the salt? Because it may interpreted like a question, because the can word often used in a question answering. Okay, so but it is not a question, it is a request. Okay, we have written it like a question format, but it gives you it presents a request. Okay, so that is called context ambiguity. At the same time, we have a last that is called reference ambiguity. Or in reference ambiguity, let's say Ravi told Mohan that he won. Okay, now Ravi told Mohan that he won. Who won in this case? Either Ravi has won or Mohan has won. Again, Rahul told that Amit that he won the prize. Now in this case, who won? So Rahul told Amit he won. So Rahul may have won, okay, or Amit may have won. So this is called reference ambiguity. So it is not clear from this whether Rahul has won the prize or Amit has won the prize. So these are the ambiguities that present in the NLP, natural language, and handling this NLP is a handling this ambiguity is a very difficult or tedious task. That's why NLP is a challenging and it is very demanding right now. Okay, now let's look at the learning approaches for NLP with linguistic knowledge. So this is a basic architecture of a NLP process where we used to find a corpus. Okay, so what is a corpus? Corpus is it's our data set. In a simple word, we can say that where we are going to train our model. Okay, so corpus is not in NLP. Corpus is not simply a raw data. It is pre-processed data which will be formatted the form supported by your algorithm that you are going to use. Okay, so we have to manually annotate and manually convert the data in the structure that your model going to support. That is the corpus. Now from in corpus you will divide it into training and validation corpus. Also from that training corpus you will train a machine learning algorithm. So to train a machine learning algorithm you will use your linguistic knowledge. Linguistic knowledge means the linguistic information that we will see how linguistic knowledge will be extracted. Okay, from that we will construct an NLP system. So construct an NLP system, it means a model that has learned linguistic knowledge from a training corpus. Now it can either predict or it can either generate. So we will now provide that raw data, where in raw data it will convert it to a corpus and generate linguistic information so that your NLP system can automatically annotate or do whatever it wants. So this is a general learning approach in NLP. Okay, up to this point it is clear. If you are having any doubt, you can ask me at any point. Okay, now let's say now the core NLP workflow stages. So there are basically these are some common pipeline where how NLP works. First one is a raw language, so it's our raw data. Then we in raw data it means it will be unstructured data gathered from the your whatever resources are available. Maybe it will be gathered from websites, maybe it will be gathered from your textbook information, or it may be gathered from any social media platform. So all the unstructured data will be your raw language. Now at the second step we used to clean the data. Okay, now clean the text, it means we will pre-process the text. Okay, we will see what pre-processing technique we have to do. Okay, then we will extract numerical features, we will see what features we are extracting, then we will use this feature to train a model so that it can predict the result. So the stages are, first stage is collect raw text data or speech data. It will be raw, unprocessed, it will be by described material or articles. So the input will be raw, unprocessed, described material. Then we will do pre-processing where we will perform cleaning and we will make it ready for the feature extraction. The data will be now formatted so that we can extract patterns or any meaningful information from the raw data. Then extraction will be there. In feature extraction, we will convert this text information to numerical sequences. Why? Because your NLP model or your whatever deep learning model, whether you are using machine learning model or deep learning model in your NLP, okay, NLP system, it is not going to accept any text information. It will accept the numerical information only. Now you have to somehow represent the text information into numerical values. So there are so many techniques. Okay, if you are using deep learning, then you don't need feature extraction. You can directly use embeddings. Okay, but in general, in NLP, we do feature extraction. It means the text will be somehow converted into a valid, informative, sequential, or numerical information or representation. Okay, we call it vectors or word embeddings. Okay, now then with these features, we will train model. Okay, once the model will be trained, we will deploy the model for the output prediction. Just give me a second. Okay, so these are the basic 5 stages of NLP workflow. Okay, now let's come to the NLP architecture. So this NLP architecture, it is between this pre-processing and feature extraction. Okay, now, so what are the NLP architecture? Because we have to extract feature and we have to pre-process the data, because it is basically, it completely dwells between this pre-processing and feature extraction. Okay, so stages of language processing is this. First, raw speech will be there. Okay, from the raw speech, we will perform phonetics and phonology, okay, based analysis. Then we will do morphological analysis. Then we will go for lexical analysis. Then we will extract synthetic analysis, then semantic analysis, pragmatics, and discourse understanding. So these are the basic pipeline or basic stages of language processing. Now, from lexical analysis, although you can extract feature, with the semantic analysis also you can extract feature. Sorry, synthetic analysis. From semantic analysis also you can extract features. So these are some high level information, and these are some word level information. So up to this synthetic, or up to this synthetic analysis, it gives you the low level features. Okay, like basic features will be related to the structure only. Then this, from the semantic to this discourse understanding, the features that here you are extracting from here will be more like an abstract feature that will, you can understand from an entire paragraph type of thing. Okay, now look at here, phonetics and phonology. It will analyze speech and sound, how our vocal cords generate sound for different words. Okay, it will be this. Now in morphology, we will study about word formation, how words are forming. Okay, for example, playing has been formed from play plus ing. Okay, this is an example. We will discuss it in detail. Okay, in lexical analysis, we will identify the word meaning. Okay, the bank, it's a river bank or money bank. Okay, in synthetic analysis, we will check for the grammar structure, whether the sentence that we are using or we are dealing with is grammatically correct or not. She eats mangoes. Now this is not grammatically correct. Okay, now semantic analysis, understand the meaning of the sentence. Okay, now apple is red, so it means, now again here there is a ambiguity. Now this apple is red, now we are talking about which apple, whether it's a, now apple is, let's say apple is very popular. If we write it like this, apple is very popular. Now that apple can be apple brand or it can be a fruit. Okay, so we have to deal with this. Now in pragmatics, we have to understand the context. Can you open the door? It's not a question, it's a request. So we will understand it like a request. Okay, that understanding will be done in pragmatics. And discourse, we will connect the sentence meaning. Now it is more like it is more like a interconnected sentences, and it will be more like a learning entire paragraph. So we have started from generating a word from our vocal cord to understanding an entire paragraph. It is generating words from vocal cords, it's a formation of words, then it's the meaning of word generated. Now the words have been structured correctly or not, dealing with grammar. Now it will be dealing the sentence meaning is correct or not. Now it is dealing with the context of the sentence, whether the context is a request or question. Now this discourse will basically try to understand the larger picture. It will deals with the entire paragraph. Okay, this is the basic flow or stages of NLP. We will discuss one by one everything. Okay, now let's start with the NLP Trinity problem. First, we need to try to understand this NLP Trinity problem. We have language, we have algorithm, we have problem. So these are called language Trinity, NLP Trinity. You can choose anything. You can choose French, you can do semantic analysis using CRF or using RNN. So it will be a form like this. Okay, you will put a dot everywhere. It will be like, you can do parsing in Marathi language using hidden Markov model. You can do morphological analysis in Hindi, okay, via, let's say, MEM. Okay, now the complexity increases as the processing increases. Morphological analysis is very easy. Then POS tagging, chunking, parsing, semantic analysis, discourse and that discourse type of thing, it will be the more complex thing. The complexity increases when the processing increases. Okay, now the level of language analysis is this. It's kind of, if we are familiar with Chomsky hierarchy, then it's basically language hierarchy. phonetics deals with speech sound. Then phonology is phonemes, how this sound has been generated. Okay, the morphology deals with word. Syntax deals with the phrases and sentences. Semantic deals with the meaning, or literally actual meaning of sentences that they want to convey. And pragmatics is basically meaning of entire sentence in its context. Okay, and this course is the boundary in between semantics and pragmatics. Okay, so this is the levels of language analysis. Now, let's the first thing that look at here. The first thing was speech and text processing. Okay, so first, before going to the phonetics and phonology, let's stick with the speech and text. Okay, now so the text is it's a kind of basically pre-processing task. Okay, so text pre-processing is basically it's a process of transforming the raw textual data into a clean, standardized, and machine readable format that can be applied to your NLP system or your machine learning system or your deep learning system. It means the raw data will be taken as an input, and from that raw data we will generate some meaningful information. Okay, and we will make it into some another standardized format so that our model can use that. Okay, why text processing is important, pre-processing is important? Because when we generate raw data, it will be having lot of noise as an irrelevant information. For example, irrelevant information means, let us assume that if you are reading a tweet, then there will be very irrelevant symbols. Let's say people are using 10 times hashtag, they are using emojis, so those emojis we won't analyze. Okay, so these are, we need to remove the noises. Okay, reduce the data dimensionality. When we reading a text, let's say if text is a one page text, okay, and in one page, let's say the information has been like let's say in that is having 10,000 words. Okay, and you are creating an NLP model from 10,000 words, so feeding 10,000 words to an NLP model, it will be very complex. So we have to reduce the dimensionality. Okay, it improves model accuracy, efficiency, because already data will be pre-processed, so some irrelevant or information will be already dropped. So the raw data, the pre-processed data will be more accurate, so it will help the model to generalize well, so that it can improve model accuracy as well as efficiency. Okay, now it standardizes the textual representation, because you cannot design a model that will be general in a with a very few resources. Okay, help the algorithm to learn meaningful patterns. So these are some common benefit of text pre-processing. Okay, now let's start with the first text pre-processing, that is called lowering the NLP. It is the first thing that we used to do. Okay, just a second. So lower casing in NLP, it is the first task. Okay, so what is a lower casing? Basically, whatever text we are reading, it may be composed of uppercase or lowercase, or it may be having both. Okay, so to make it standardized, we will keep everything in lowercase. Now without lowercasing, let's say apple will be written like this. There is a chance that it is apple and this is apple. Now without lowercasing, these three are not same, because A is capital, it will be having different. Let's say if we are representing into decimal values, somehow we will convert it, its value will be different. Here its value will be different when we represent it to a numerical information. So to remove that ambiguity, what we used to do, we will convert it into lowercase. So before lowercasing, it was like this. After lowercasing, it will be like apple. Okay, why this? Because NLP system treat these three as a different tokens. Okay, so tokens will be, we will see, token is the basically smallest unit of your NLP or your sentence. Okay, so basically, if the words are differently arranged, because we can extract token in character level, or it can be extracted in word level. So when we are extracting it in character level, that A and small a and capital A will be different. Okay, so that's why these three may appear as a three different tokens. To avoid this, that's why we will basically lowercase it, so that it can generate the same token. So NLP system treats them different token. Okay, these increases. At the same time, if we don't lowercase, then vocabulary size will drastically increase. Okay, because we have so many ways to write apple if we are using caps letter and a small letter. Okay, each sentence can be written in a two ways, either a small letter and capital letter. So we will be having 2 cross 2 cross 2 cross 2, 2 power 5. It will be 32 types of, in 32 different ways we can write an apple. So simple apple having same meaning can be having, can we have 32 different tokens. So it will drastically increase the vocabulary size. So vocabulary size is basically word size. We will use it, okay, to convert the word into a sentence, a word or sentence into a numerical information. At the same time, data sparsity is there, computational complexity will also increase. So what is the benefit of lowercasing? First, reduce the vocabulary size, improve the token frequency, enhance the consistency, and it will also improve the model efficiency at the same times. Okay, now let's take some case study here. Let's say vocabulary reduction is, look at here. Original text was AI is powerful, dot AI is transforming industries. This is my word. Okay, now without lowercasing, when we generate the vocabulary from this sentence, so we will be having total 5 vocabularies. This first vocabulary is capital I, another vocabulary is small I, then powerful is another vocabulary. Okay, then sorry, another word, then transforming is another word, and industry another word. You may be confused why I am not using is, because this is a stop word and we will remove it. Okay, we will see in the next step, we will see how stop words will be removed. Okay, stop words are those words which is having very high frequency. The thing that is occurring very frequently will convey a least information. Okay, so this is won't be having very much, won't be having a much information. That's why we will drop each. Okay, so it will be, we are considering unique words only. So AI, a small AI, powerful, transforming, industry. So these are my vocabularies. So vocabularies is basically all the unique words present in your sentences. Now let's say if we divide into a 2 parts, so we can write it numerically where AI is present or not. So AI is in this case present, so we will write 1 here. For small AI is present, we will write 0. Powerful is present, so we will write 1. Transforming is not present, so 0, no 0. So it will be like 1 0 1 0 0. So that's how we can convert text into a numeric information or binary information. That is the one way we will see. Okay, now with lowercasing, the vocabulary size will be now reduced to 4. We have lowercased everything. Now entire text has been in lowercase. AI is powerful, AI is transforming industries. Okay, now AI, powerful, transforming industry, these are 4 different words present in our vocabulary. So vocab size is 4 now. Okay, now another case study is search engine retrieval, machine learning. Okay, query is machine learning. So machine learning basics, machine learning application, these are basically 2 same machine learning basic, and these 2 these are 2 different things. If I am searching machine learning, so there is a chance that someone has written machine learning basic, so it will extract this machine learning from this. Okay, match, it will match. This machine learning application, it won't match it. Okay, if it is not lowercase. So if everything is in lowercase, then it will match with this also and with this also. Okay, without lowercasing, if we will search, then these 2 won't find, because there will be difference. Okay, okay, if all are in lowercase, then this first 2 term will be matching directly. Only 1 term is mismatched, that is basic and application. So the similarity will be high and you will get the result. That is another thing. Okay, sentiment analysis, I love this movie and I love this movie. Without lowercasing, love and love will be different, treated as a different features. Okay, with lowercasing, it will appear, it will be same. Okay, now let's take another basic preprocessing, that is called removal of punctuation. So punctuation is basically symbol or special character that usually do not contribute any semantic meaning. Okay, these are called punctuations. For in this case, this is punctuation. Okay, this inclination mark. Okay, now eliminate punctuation symbol and special character that usually don't contribute anything. These are just fancy thing. Okay, it won't contribute to the actual meaning. So we will remove these character. This character, maybe it can be this mark, question mark, dot, it can be colon, it can be semicolon, it can be bracket of anything. Okay, we will remove it. What are the benefits of removing this? Simplify the token, because we won't be having special symbols. Okay, then if it is having, it is in connection now, this hello and this hello will be treated as a different token. Okay, when if we remove it, these 2 will be same. Okay, so at the same case, if you with question mark without any gap, so it will be you question mark and you, these 2 will be different tokens. If you remove it, so these 2 will be same. Okay, now benefits of, it simplifies the tokens, it reduces the unnecessary tokens, it will reduce. Now in this case, it was unnecessary token and it was unnecessary token, it will be reduced. It will improve the text normalization. So it is very useful when we are counting bag of words, TF-IDF, and statistical NLP model. We will discuss these also, okay, in later. Now, punctuation removal, some examples, look at here. Sentence we have taken, hello, how are you? We have removed this punctuation symbol, these two punctuation symbol. Now, these are hello, how are you? At the same time, AI, ML, and NLP. So the commas are there. So we have removed comma. Contact me at gmail.com. So we have removed at the rate from here. Now prices is in dollar, has discount. So price is dollar discount. We have removed this. Now mathematical symbol plus and equals to we have removed. Now you may thought that because we are doing about sentiment analysis, na, so we have to remove this. Now social media text, wow, there is a three punctuation symbols. NLP is awesome. Then there is a emoji. We will remove everything, this and this. Okay. Now bracket symbol. Look at here. Machine learning has been written as an ML. So this bracket will be removed. Mixed symbol like Python. This colon is there, easy to learn with the two hyphen. So we will remove it and we will write it like Python easy to learn. We will deal with this how it is there. Okay. Now importance observation. Let's look at here. Something punctuation may carry meaning. Look at here. Let's eat grandma. Now it's a basically invitation to eat. We are saying our grandma that we can eat together. Let's eat. Now let's eat grandma. Different punctuation. Why? In this case, we are saying our grandma that we will eat together. And in this case, we are saying that we have to eat grandma. Different meaning. Okay. So it's we have to deal with in NLP in this case. But to standardize the language, we need to remove the punctuation. Okay. Up to this point, it is clear. If you are having any doubt, you can ask me. Now, another pre-processing is removing stop words. So what are the stop words? Stop words are those words which is very frequently occur in the sentences. These words are having very high frequency. So since it is having very high frequency, then there will be very low chance that it will convey very much information. Okay, generally we know na, uncertainty theory says that if occurrence of anything, the occurrence probability of anything is low, then that will convey most meaningful information. Okay. Why we remove this stop word is that been motivated from this uncertainty theory. For example, let's say the little boy is there. Let's say name of that little boy is Mohan. Okay, Mohan father goes to office daily. Okay, every day, including Sunday. And daily he brings some chocolates or some gift to them. Okay, now first day when Mohan his father goes to office, he brings toy. Okay, now let's say toffee. Okay, let's say pork he brings. Another day he brings another toffee. Another day he brings another trophy. Another day he brings another trophy. Okay. Now in the fifth day, Mohan will be certain that his father is going to bring the toffee. So he won't be any excited. First day he was excited that his father was bringing some gift. But in now, after 4 consecutive days, he has seen that his father is daily bringing some chocolate or toffee. He won't be excited because he was already known that there is 100% chance that his father will bring toffee. Okay. In this case, the uncertainty comes. The fifth day, if his father brings his a toy like a helicopter, and the boy sees helicopter in his father's hand, he will be very excited. Why? Because he was not ready for that. He was thought that the toffee, his father was supposed to bring trophy. There was zero probability that his father will bring a toy. So since the probability was very low of happening some event, it gives you the most information in terms of happiness. Okay, that's why the frequency of a word is very high. Then there is a chance then this word will convey very less information. That's why we will remove it. So before the cat is sitting on the table, sorry, on the mat. So we will remove, we will keep cat sitting mat. We will remove all the stop words. So benefit, it's reduce the space dimensionality, computation cost will be also reduced. It focuses more like on unique words rather than frequently occurring words. Okay. It is very useful in search engines, topic modeling, and document classification. Now let's take some case studies. Now we have search engine optimization. Look at here. User queries. What is the best book for an NLP? Okay. So after stop word removal, it will be best book NLP. So search engine will focus on these 3 words only: best, book, NLP. If it finds any these 3 words in any sentence, it will retrieve it. Okay, at the second case study, let's take as a document classification. Now, original sentence: this movie is one of the best movie in the world. Movie, best movie, world. Okay, So after this stop word removal, this sentence is like movie, best movies world. So important terms dominated feature extraction. In this case, these terms are important. So okay. Now in third case, TF-IDF, that is term frequency and inverse document frequency. We will discuss what it is. So it helps without a stop word removal, the high frequency words are there. It will basically influence this TF-IDF. We will see it. Okay. Now let's come to another thing, that is tokenization. Okay. In tokenization, what happens? Basically, it's a process of splitting the entire text into smallest unit. Okay. Of that can convey meaningful information. Okay. So tokenization is a process of splitting the text, okay, into smaller meaningful units called tokens. Token can be anything. It can be word token. If we are dividing it to a word level, so it can be a word token. If we are doing it a character level, the character can be also a token. Okay. It can be a sentence, it can be a subword, or it can be a character. So sentence means a sentence level tokenization means from a paragraph we will extract multiple sentences. And subwords means basically subwords, let's say state of the art. If we write it right, we write state dash of dash dash the dash art, we write it na. So subword will be the state of the art separately. Okay, these are the subword. Okay, now we will call we will do character level tokenizations also. So look at here. So basically, if I am writing I love NLP, so after tokenization, it's a word level tokenization. I will be another word, love will be another word, NLP will be another word. So we have generated 3 tokens from this sentence. Okay, so why tokenization is important? Because it converts raw text information into possible or processable units. So first, it's a basically very first step of NLP pipeline. Okay, it is very useful in feature extraction, as well as it is very required step for MLP, machine learning and deep learning based NLP models. Okay, so this is the tokenization. Now, let's comes with the first phase. Look at here, we have multiple phases. Na? I have already told. Look at here. This was the speech. We have already discussed pre-processing. Then we have to discuss the phonetic and phonology. Now let's discuss the phonetic and phonology. Now, what is phonetic and phonology? So these two are very common terms. Phonetics is the study of speech sound. Okay, how sounds are produced, transmitted, and heard. This is basically phonetics. So basically, phonetics is a branch of linguistics, deals with the generation, transmission, and view of a speech sound. In other words, it is the study how human speech sounds are produced. This is the phonetics. And phonology is basically the study how speech sounds are organized and used in a language. Okay, so basically phonology focuses on the pattern, how it is using, whereas phonetics is basically pronunciation. Okay, so it's a phonetics is a study of pronunciation, and phonology is basically a study how speech sounds are organized in and used in a language. That is called phonetics and phonology. Okay, now phonetics it focuses on punctuation, sound production, and sound characteristics. Okay, so basically in simple way we can say that phonetics study shows how humans physically produce or hear sounds. Okay, for example, we are writing pat and bat, then P-A-T. P will be having, if I am separately saying P-A-T, it is having phonetic, different phonetics. And if I am saying pat, then it is having different phonetics. Okay, so the phonetic based thing is done by Google Translator, where we can literally pronouncing and it is herding it and it is processing it. Like Google Alexa, like Google Translator, from where we can say and it can translate. And Alexa, see, these are common examples where phonetics or phonology has been used. Okay, in phonology, we used to learn about the sound patterns. Okay, how they has been arranged. For example, it will study about the sound pattern, punctuation rules, and relationship between different sounds. These are phonetics and phonology. Now, these are what is a common difference between phonetics and phonology. The first thing, phonetics is a branch that deals with how human produce sound, and it contrasts this. Phonetics is basically a study how significant speech sounds. Okay, it describes the physical expression of human speech. Okay, in other hand, the phonology deals with the mental aspect of the sound. Okay, in phonetics, phonetical units are phonemes. The smallest sound production unit that we produce is called phonemes. Okay, and phonology units are called phonemes. Okay, so these are common difference between phonetics and phonology. Now, the first thing is the morphological analysis. Okay, so what is a morphological analysis? Okay, so morphological analysis is basically process of analyzing the structure of word. Okay, it focuses on word level. Okay, so this morphological analysis is basically process of analyzing the structure of word by breaking them into smaller meaningful units called morphemes. Okay, look at here. It's a definition. Morphological analysis is a fundamental concept of in linguistic and NLP. It involves breaking down the word into their smallest meaningful units called morphemes and understanding how the units combine to create different word form. Okay, it focuses on this word formation. So morph, and what it will be this, look, we have to focus on this morpheme basically. So morpheme is what? It is basically the smallest meaningful unit of the language. Now let's take an example. Now if, let's say, if I am saying unhappiness, if you are having any doubt, you can ask me. If anybody is having any doubt, you can ask me. Okay, now, so what is, now let's take an example. Let's say if I am saying unhappiness. So unhappiness, we will divide it into morphemes. The morphemes will, so morphemes, it's unhappiness may look it's a single word, but the morpheme is the breaking down this word into another or smallest possible meaningful information. So we can divide it into un, happy or ness. So un will be not, happy, it will a root word of this unhappiness, okay, which represents the happiness. Okay, and ness is basically state or condition. Okay, so this three, we can divide unhappiness into three morphemes: unhappy, ness. That is basically a simple example of morphological analysis. Okay, in simple meaning says that morphological analysis study how words are formed together so that it can generate the possible meaning from the smallest meaningful parts. Okay, other another example, we can say that playing. Okay, so play will be a root word, or ing will be a suffix showing a continuous action. Na? So playing, basically play means we have to, somebody is play, or ing means continuously he is playing. Okay, so we will be having two morphemes, play and ing. Okay, why we need? Because we need to find the root word. The root word basically gives you the actual meaning. Okay, so in morphemes we have to find the root morphemes, we have to find the prefix, we have to find the suffix, we have to find the free morphemes. Free morphemes can be a standalone morpheme, like example book. Book can be there won't be any morphemes associated with this. Book will be a standalone morpheme, we call it free morpheme. Bounded morpheme, let's say bounded morpheme means example is ed or ing. Okay, for example, fast forwarded, okay, or playing, these are example of bounded morpheme. So in what morphological analysis does, in morphological analysis what we used to do, so we used to do four things. We used to identify the root word, used to detect the prefix suffix, determine the grammar role, and to extract the meaning. So these are the that is the morphological analysis. Okay, now, so these are the importance of morphological analysis. To understand the word formation, it helps. Okay, it helps improving the text analysis, it improving the enhancing the language model, and it facilitating the multi-language processing also. So these are common importance of uh, morphological analysis. Now let's see what is the key techniques used in morphological analysis. The three key techniques that we used is stemming, lemmatization, and morphological parsing. Okay, that is the basic. So what is a stemming? So basically we will discuss it in detail also. So we have to understand these three techniques are used in the morphological analysis. One is known as stemming, another one is known as lemmatization, then we have a morphological parsing. Now let's see what is a stemming first. So stemming, So stem, it has been come from stem. So basically stemming reduces the word into their root word. We have to cut the stem so that the tree can grow in the right direction. Now that is, we do stem clipping. Okay. Now in stemming reduces the word into their root word or base form by removing the prefix and suffix. Okay, that is called stemming. For example, let's take an original word. It's a playing. Now, so playing, the root, it's a original word, and stemmed word where we have removed the prefix, it's called play. It is the root of the word. It is the carrying the actual meaning. Connected, we have removed the ed. Now it is connect only. Studies, so it is study, where in this case it is I, but actually the meaning will be y, na? But the phenoms is same. Okay, so how stemming instead stemming works? We will take input, the actual original word. We will remove the prefix or suffix. Like in this case, we have removed the ing, so that we can achieve or we can get the root word, play. And the importance of stemming is now, so that a single root word can have different uh, uses. Na? We can write play in form of plays. It can write in form of playing, or we can write it in form of played. Okay, so a single word will be having three different forms, na? Or multiple different forms. So the vocabulary size will increase. Okay, we will see how vocabulary size actual helps in the feature extraction. So vocabulary size will drastically increase. So if we reduce the word to its root word, then multiple word will be having same root word, and the root word will take place in the vocabulary. So the vocabulary size will be reduced. So since vocabulary size will be reduced, so whatever feature we will extract, it will be having very low dimension, carrying unique words only. If we are saying place and playing in the same vocabulary, the two will be a similar meaning. Okay, so the feature will be redundant. So it improves in search efficiency also. It helps text normalization, because all the text will be normalizing. They will be having the same form, root form. Na? There will be no prefix suffix. So it is useful in information retrieval search engine. Why? If I have to search for playing, then plays and playing both will be comes in same category, because the root word is play. It will extract the terms related to play, and it will extract the term related to playing. That's why stemming is very important. So stemming improves the NLP efficiency by reducing the related words to a common root form, helping the model to process textual data more efficiently. Okay, now let's take some case studies. Now let's take first case study, that is search engine retrieval. Now user put this query connect. Okay, it has to retrieve information related to connect. Now documents having these titles: connected, connecting, connection. Okay, so without stemming, when we match the cosine similarity between these two, it will be high. Cosine similarity will be high. Cosine similarity will be high this case. Okay, when we stemmed down these words into their root form, so it will be a single root, na? Connect. In this case, ing will be removed, connect. In this case, ion will be removed, and it will be connect. So all these three words will be having same root form or same stemmed word. So with stamping, it will be connect, and now we can match it. So it will be having very low cosine similarity score. So it will be highly similar. Okay, so that's why it helps in a search engine for a information retrieval. At the same time, when we are talking about document classification, look at here. Players are playing football. So players played football. These two are same. Okay, now without stemming, the vocabulary will be like players. Then we have players, we have player, we have playing, we have played, and we have football. Okay, so vocabulary, it's just a vocabulary related to play only. Na? Football is unique word, and the four words are same. So the vocabulary will be like 4 for this and football for 1. The size will be 5. If with stemming, then this entire 4 vocabulary will be reduced down to only 1. That is play. Okay, so that's why it reduces the vocabulary size by keeping only meaningful information or unique information. It will be won't having overlapping information. So the features will be not overlapped. It will be having more unique features. So it ultimately improves the document classification result. Now we have in information retrieval. Let's say we have written query as a compute. So matching word will be computer, computing, computed, computation after stamping only. Okay, so this is the common technique of stemming, where we remove the prefix and suffix to reach to the root word. Okay, now next is the lemmatization. So what is a lemmatization basically? So the lemmatization is combination of lemma. It is generated from the word lemma. So lemma is nothing but, it's a Greek word. It is basically dictionary form. Okay, so lemmatization is process of converting a word to into its base or dictionary form. That is called lemma, using vocabulary knowledge and grammatical analysis. So for example, original word it was playing, the lemma is play. Studies, the lemma is study. Now in this case, if we are stemming it, it will be play, na? So it is correct, same lemma is there. But in this case, look at here, it is study. We have removed es. The stemmed word was studi, but that was not correct word. So we will go to study. That is the lemma. So better, its lemma word will be good. Running, its lemma word will be the run. Okay. So how it works? Basically, we will be having words. We will look for the dictionary and grammar rules. Based on that, we will go for a base case or base form. That is called lemma. So why lemmatization is important? Because it produces meaningful root words, uses dictionary or part of speech tagging is also, it is very useful. We will see what is part of speech tagging is after a few slides. It improves in semantic understanding. It reduces the vocabulary size. Okay, now let's discuss some case studies. So we have this search engine retrieval. Na? We have written run. Again, we have in documents, we are having running, runs, and ran. So after stemming, this running and runs may same, na? Because run, after removing ing, it will be run like thing. After removing s, it will be run. But this ran is another form of run, na? But both are having the same type of meaning. The context is different little bit. Okay. Now, so after lemmatization, this all the three will be having same root word or same base dictionary word, that is run. So these three will perfectly match with run. Okay, another example is sentiment analysis. The movie was better than expected. Okay, so after lemmatization, this better will be basically, it will be good. The movie was good than expected. So helps models to understand the semantic similarity between better and good. Improves the sentiment interpretation in this case. We have another chatbot question answering case study. That is, let's take user input. Students are studying NLP. Okay, so students, it will be removed, R will be removed, ing will be removed, NLP will be removed. Student study NLP. So chatbots understand the core meaning of the question that we have asked, that student study NLP. Okay, now we have machine translation. He was driving cars. Okay, lemmatization form will be he will be he, was will be the be, driving will be drive, and car will be car. So we have this root information so that it can be translated. So these are common example of lemmatization. Now, in morphological analysis, that is a parsing. Okay. Now let's we have two types of morphemes. We know now what is morpheme. Morpheme is the smallest meaningful linguistic unit that cannot be further divided. Okay, it will be the smallest meaningful unit. Okay, so we have two types of morphemes. First one is the root morphemes, another one is the affix morphemes. So root morphemes are basically carry the core meaning of the word. Okay, it cannot be broken down further without losing the meaning. For example, let's take an example. Child cannot be divided further. Play cannot be divided further. In terms of Hindi, bacha cannot be divided into any subparts, or khel cannot be divided into any subparts. These are called root morphemes. Affix morphemes are basically, it's some modified morphemes, modify the meaning or grammatical function of the root. Okay, can be prefixes or can be suffixes. Okay, it can be after root or before root of things. For example, e, it's a basically feminine suffix. A, it will be a plural suffix. O, it will be basically oblique plural suffix. So these are the morphemes. These are also morphemes, na? But these are basically prefix and suffix part morphemes. That's why we call it affix morphemes. Okay, now let's consider the Hindi language, and let's see the grammatical categories, how Hindi words can be analyzed according to the several grammatical features. So the first is based on gender. Okay, so we have masculine and we have feminine. So if we are writing ladka, then it will be masculine. We are writing ladki, it will be feminine. Ghar. Okay, we have pustak, these makan, kitab, bazaar, and maze. Basically it gives the information about the gender of a word. We use this feature in NLP. Okay, then there is a number, that is vachan. It can be a singular, it can be a plural. If we are writing bacha, then it will be a singular. If we are writing bacche, if it is having a matra, then it will be a bacche. So from bacha it will generate child, na? From bacche it will generate children. Then we have a case, that is karak. We have direct case and oblique case, that is karta karak or kam karak, used when no post position follows the noun. Okay, in this case used when the post position follows the noun. Okay, common Hindi punctuations are ka, ki, ke. Okay, so all this ka, ki, ke, actually it goes to off only in English when we do translation. Ko basically it goes to to. May it goes to in. Say it goes to form. So these are how we do mapping. Na? Okay, these are some grammatical categories. Now, in basically morphological analysis, we do the add delete table methodology. Okay, so what is this add delete table methodology? This add delete table methodology is systematic approach in morphological analysis to identify what to delete, what to add, and the result. So what to delete means which part of the root word needs to be removed so that we can go to the root. Okay, and what to be added, which suffix or affix need to be added to create the word, and result the final word from which the grammatical with its grammatical feature. So that is the add delete table methodology. Now let's take root word bacha. We have written and we have bacha, the two root words we are having. Now targeted word is bacche or bachon. Okay, so we deleted a, we have deleted a ki matra and we have added a, so it becomes bacche. It's a plural form. Earlier it was a singular form. Okay, now this bacha, we have deleted the same thing, a. What we have to delete, we have to identify, and what to add we have to identify. We have added on, so it created bachon, but it's the same plural oblique formation. Okay, so table structure, in this case look at here, we have to add a o. Okay, these are singular plural case, but in direct or oblique case, so it generates bacha, bacche, bacchen, bachon. So this is the morphological analysis that uses add delete table methodology. Now we have paradigm classes in Hindi also. So what is a paradigm classes? Concept of paradigm classes is it's basically the morphological pattern belonging to same paradigm classes. So what will be this meaning? So words that are having same morphological pattern will be having same paradigm class. So basically we have to identify word and their morphological patterns so that we can find the paradigm class. This means they will be having similar transformation across different grammatical categories. For example, look at here. This is masculine noun ending with in or a. So it will be bacha, ladka, makan, kamra, darwaja. All are ending with a. Okay, so it is called masculine noun. We have feminine noun. Look at here, all with ending with e. Ladki, admi, gadi, khidki, kursi. These are ending with e, so it comes under feminine noun. Feminine nouns ending in constant or other vowels. Look at here. Pustak, ke, kitab ending with ba, mej ending with ja, chadar ending with ra, dukan ending with no. So these are ending with different other vowels. So this comes under feminine noun. Now masculine noun ending with consonants. Look at here. It is ghar, paid, fool, bistar. Okay. So all are ending with different consonants. Then we have invariant nouns, that is pani, water, okay, doodh, milk, chai. These comes under same invariant noun classes. So these are some categories or paradigm classes. Okay, so how morphological analysis actually works? Identify the root words, first step. In second step, what we do? We analyze the grammatical features. Okay, in root word we determine the base form, lemma form. Okay, in analyze the grammatical feature, we identify its paradigm classes, the gender, the number, the case. Then we apply add delete rule, use the systematic table approach that we have seen. Then we verify the result, ensure the transformation produces the correct form or not. Then check the paradigm consistency, verify the pattern that has been generated follows the same paradigm class or not. Look at here, we have word of ladko. So ladko means it's of boys. So root word was boy, deleted a, added feature will be masculine, plural form, oblique case. So paradigm class will be ending with a. Okay, so these are the features that has been generated from this. Okay, now application of morphological analysis. There are wide application of morphological analysis. Information retrieval, it is very useful because we have to go to root word. Then from root word we can form so many words, okay, and it will fall under same category or same parallelism class. Okay, we can, it is very useful in machine translation, okay, text to speech systems, it is very useful. Spell checkers and grammar checker, it is also useful. And name entity recognition also, it is very useful. These are the application where we go for the morphological analysis. Okay, now let's come with a lexical analysis. Now, what is a lexical analysis? The basic definition of lexical analysis, that lexical analysis is the process of converting the sentence or text into smaller units called a token. Okay, so token can be a complete word, it can be a symbol or a special symbol, or it can be a phrase, and analyzing their meaning. So lexical analysis will first trim down the entire sentence into word or tokens, which will be the smallest unit, and that will and analyze their meaning. So in NLP, the lexical analysis helps the system to understand, basically try to understand the words, vocabulary, the spelling, or a world level meaning. Okay, so simply we can say that lexical analysis basically it breaks the text into meaningful smaller words, and those smallest word will be the tokens. So it to do two things. One is known as tokenization, and another one is known as POS tagging. That is part of speech tagging. Okay, so in tokenization, it will divide the entire sentence to a smallest chunk called tokens. For this example, I love programming. So the token would be I love programming. Will be a token, love will be a token, programming will be a token. Okay, then second is part of speech tagging. So part of speech tagging means part of a speech. So speech, it means sentence, and part means part of a sentence, and tagging, we will tag it to its basically grammatical rules. Okay, whether the part of that speech is a noun or pronoun, or it will be adjective, or it will be a verb, or it will be any other thing. Now let's take an example. I am reading a book here. Okay, so in this case, tokenization, it will be, we will have to break down it to a word level tokenization. There are three level of tokenization. We will discuss that also: word level, character level, or sentence level. In this case, we are doing word level tokenization. So it is I am reading a book. So I am reading a book. So we have 5 tokens. Okay, so now part of speech tagging will tag all the part of speech to their category. For example, I is pronoun, so it will be rated as a PRP. Okay, M is a verb, so we will write VPP. Reading is a verb, so it will write VBG. Okay, A, it will be article, so we will write DT. Book is a noun, so we will write NN. So that is what this lexical analysis do: tokenize and part of speech tagging. Now, what is the importance of lexical analysis basically? So importance is basically word level identification. It does word level identification. It identifies the word and try to find their meaning. And at the same time, it do text simplification. Just a second. Okay. Now, let's discuss the tokenization in detail. So basically, tokenization is the most fundamental step in the NLP. It involves dividing the textual information or textual input or corpus into smallest unit called token. Okay. Now, these tokens can be, we can have different tokenization: word label tokenization, character label tokenization, subword tokenization, and sentence tokenization. Now let's talk about just word label tokenization. Then we will be having a tokenizer. It's just a function. We have to pass this information to this function. Tokenizers are available in Python. Okay, in last day, if you want, we can show during the model capstone project. Okay, so I love machine learning. It will pass to a tokenizer. Tokenizer will tokenize. So whether we have to mention which type of tokenizer you want to use, whether word level, character level, or sentence level. So it will generate I love machine learning and this exclamation mark as a token. Okay, now so we have this, I have already told, we have word tokenization, character level tokenization, subword tokenization, sentence tokenization, and we have n-gram tokenization also. I will discuss this n-gram tokenizations also in detail. Now let's discuss everything in detail. Now, first come to with the word level tokenization. So what word level tokenization is? Word level, basically, it's the most commonly used method, and it's divide the entire text into individual words. Okay, it works well for almost all the language, because we know now word boundaries are very common in the word boundaries are very, it's a very fixed in all the languages, so it is very easy. And especially in case of English, using word label tokenization is also very effective. So we have this machine learning is fascinating. So we will be having 4 tokens. Machine learning is fascinating. Once this tokenization, this token will be there, then we will remove all the this stop words, na? Because we need to identify, na? So here we will do POS tagging. We will tag these words. Okay. Then this is will be a stop word, so we will remove it. That's why it is useful. Now, in character tokenization, rather than dividing it into word level, we will divide into a character level. Okay, the textual data will be splitted and converted to a sequence of individual character. That is called character level tokenization. Okay, now look at it there. We have this you are helpful. So it will be literally, it will be written like you, you are helpful. Okay, now it will be also helpful in case even spaces will be there. Look at here. Okay, in character level tokenization. So you, it will be uppercase, so we will down the lowercase it. Okay, so this is useful. Okay, so basically word level tokenization and character level tokenization, it is clear. Now we have subword tokenization. Subword tokenization is basically, it is basically divide a single word into 2 different subwords which can convey the meaning. Okay, the strike a balance between a word. Character tokenization, it's basically both. It is a basically hybrid of character or word tokenization. So it breaks down the text into units that are larger than single character but smaller than full word. For example, we have this timetable. No, earlier it was a timetable, so we have trimmed down into time and table. We have raincoat, so we have tokenized into rain and coat. We have gracefully, we have tokenized into grace and fully. We have runway, we have tokenized into runway. So subword tokenization helps to handle out of vocabulary word in NLP task. Okay, for example, we can fix this and we can have this. So we can combine this so that it can generate timetable. Okay, then we have the sentence level tokenization. What is sentence level tokenization? And sentence level tokenization is also a common technique that uses. It uses generally, if we are reading in paragraphs, then the sentence level tokenization will extract sentences. For example, earlier we will having this paragraph. Now, artificial intelligence is an emerging technology. Machine learning is fascinating. Computer vision handles images. So it will generate 3 tokens. This first sentence as a first token, this second sentence as a second token, and this third sentence as a third token. So it will generate 3 tokens. Now we have this n-gram tokenization. Now this n-gram tokenization, where n is a number. Okay, n-gram means occurrence of that number. Okay, so n-gram tokenization split the word into fixed size chunk. Now it can be word level or it can be character level also. So if you are using word level tokenization, look at here, input tokenization, machine learning is powerful. So now if you are using bigram means the value of n is 2. So it means it will take 2 words at a time and it will create a token. So look at here, how much 2 words are there. Machine learning was the first 2 word pair. Then learning is was another 2 word pair. Then is powerful is another pair. So these generate 3 tokens. Machine learning as a first bigram token. Learning is another bigram token. Is powerful another bigram token. If it's a word level. If it can be a character level, then it can be MA, it's a bigram, then AC, then CH, then HI, then IN, then NE, then E space. Okay, this will be the character level tokenization of n-gram tokenization. Now, if you are using unigram, so it will be a straightforward single words. Okay, word level tokenization. It is, you are using bigrams, so 2 grams are there. It will be basically consecutive pair of words. Okay, natural language, deep learning to understand this. Okay, if you are using trigrams, so it will be 3 consecutive words. Machine learning model, data science approaches. Okay, look at here, 4 gram, 5 gram, you can use whatever number you want. So these are sequence of 4, 5 and more consecutive words. So these are n-gram example. Okay, now look at here, if n is 1, then it is extracting this is a sentence as a unigrams token. Look at here. If this is a sentence, if you are using bigram, so first 2 sentences, then next 2, sorry, first 2 words, then next 2 words, then next 2 words, it will extract 3 tokens. Okay, now you are using trigram, then first 3, then next 3. It is generating only 2 tokens. So look at here, the number of tokens is also changing. Okay, up to this point, it is clear. Okay, now let's go to the next. So I have already discussed what is a tokenization and what is the significance of tokenization. We have already discussed in every slide. Now, application of n-gram tokenization, it is very helpful in speech recognition, machine translation, predictive text input, name entity recognition, and search engine algorithms. It is widely used in this speech recognition, machine translation, predicting text input, okay, name entity recognition, and search engine algorithm. Okay, now let's go to the some case studies. The first case is using n-gram to predict the probability of sentence. Okay, we are using an n-gram to predict the probability. Here, it is a corpus. Whenever we will prepare a corpus, we will put this S symbol, which denotes the starting of sentence, and this backslash S symbol that denotes the ending of the sentence. Okay, so S, this S. So I am a human, I am not a stone, I live in Mumbai. So this is my corpus. So we can call it our training data. Now we will use a statistical probability based model to predict the probability of a sentence, whether the chance of that sentence is, what is the chance of having that sentence. So now check the probability of this I am not. We have written this sentence. Now we have to find the probability of this using bigram. So now, so for finding this, we need to P I am not. It is actually what? It's a I. Now let's find out the bigram. It's I, whatever, look at here, na, I am not, na, it is there, na. So what are the probabilities? We have I, okay, then another I, then M, then not, na. So basically the first I, so first I, so look at here, the first I will be always present with the S. So presence of I just after S. So we are known with the S and we are calculating the probability of I. It's called conditional probability. We are known with the S, and when S is known, then having chances of having I. So it will be I in presence of S. It will be another I in presence of I. It will be M in presence of I, because I is already known and we are finding the value of probability of M when I is there. Then we are finding the probability of not when M is known. So it is, we are finding probability of not when M is known. And at last we are finding the probability of this ending statement when not is known. So this is what, if we have to find the probability of I am not, then we have to use probability for 1, 2, 3, 4, 5 bigrams. Okay, now let's find, it's a conditional probability, you must know. So count of S and I divided by the total count of S and I. So look at here, count of S and I is 1, 2, 3. Okay, so total count was, look at here, 3 divided by total count of S. So we have 3. So it has been 3 into, next, it's a count of I in I. So just I after I. Look at here, I after I, it has been occurred just 1. We have this bigram. The count of this, it is just basically count of that bigram. So it is 1. So 1 divided by count of total I, it is 4. So it is 1 by 4. Look at here, it is 1 by 4. Now count of I and M. So look at here, I and M, it has been occurred just once. So it will be 1 here, and I am here, it is 2. So 2 divided by total, look at here, total count of I, so it will be 4. So it will be 4, 2 by 4. At last, it is M naught. So it will be pair count of M naught. So look at here, M naught, that is 1. So it will be 1 divided by total M. So total M is 2. So it will be 1 by 2. At last, P and stop symbol. Sorry, not and stop symbol. Okay, so count of not and stop symbol pair. Okay, so look at here, there is no not and stop symbol bigram. So it will be, count will be 0 simply, and divided by will be total stop sentence symbol, that is 3. So 0 by 3. So ultimately it has been multiplied by 0. So it is 0. So probability of having this sentence is 0 in your if this sentence has been generated, then the generation of this probability, generation of this sentence with this corpus is a 0. Okay, now let's take another example. Okay, we are using n-grams to predict the next word in the sentence. We have to predict the next word. Okay, now this is our corpus. We have 5 records. I am Jack, Jack I am, Jack I like, Jack I do I like Jack. Okay, and all the sentences has been put in the start symbol and ending symbol. Okay, now based on this, we have to use bigram model only, and we have to check. We have to basically find the next possible word. If it is Jack, the next possible word, Jack I do, Jack I am Jack, do I like Jack. Okay, so we have to find the next possible word. using this bigram model. So look at here, this was our corpus. So first we need to find the all possible bigrams. So all possible bigrams are, look at here, sentence I am, jack, jack this ending symbol, starting symbol jack I am this is starting symbol. So we have to consider all this bigrams. So this is first bigram, I when s is known. So I when s is known, the occurrence of this is only once, divided by total s is 5, so it is 1 by 5. Next, am I, when we have to find m when I is known. So I am, so m with I, it is just once, twice, divided by total I. So total I is 5, so it is 2 by 5. In this way, we have to calculate all the probabilities of all bigrams. So once all the probabilities of all the bigrams will be calculated, then first case we will take, that is jack. The next thing, something we have to predict, na? So it is something by jack. So look at here, something by jack. Okay, we have to predict something by jack, na? So look at here, something by jack is there or not? Something by jack, look at here, if jack is in the bottom, look at here, something by jack, this I, something is there and jack is there. Okay, now look at here, so we have this and there is another, na, something by jack, it is something and jack. So we have two only, something by jack. First case is this, second case is this. The probability of this is 2 by 5 and probability of this is 3 by 5. So we have two cases, that are, the jack will be first it will be the first symbol. Okay, the next symbol will be this ending symbol, so it will be 2 by 5. And if it is I jack, it means jack is known, the next sentence is I, the bigram will be jack I, so it is 3 by 5. So basically the probability of having I after jack is high, so the next probable symbol will be I in this case. Look at here, jack I do. Okay, so it is jack I do, so we have do something, you know, so something, then we have do. So look at here, something then do. Look at here, where is it do? Here it is only one, like, it is probability is 1 by 2. So we have I do like, there is one more, I think. Look at here, do here, do here. So we have two possible symbols that can appear just after do. One is like, one is I. Both is having same probability, so you can choose anything. Either you can choose I or like. Okay, so this is how we do. The for rest, these two cases you can compute. Something jack, the same probability. Something like, you can check. Something like, so the like followed by some sentence. Like is already known. So look at here, like is already known in this case. It is this, like will be the last sentence, and like will be the like jack will be just after like. So it will be 1 by 3. In this case, it will be 2 by 3. So there is a chance that for this case, it will be the last sentence. It will be the end of word, end of sentence. So this is how we used to do. Now next come with the POS tagging, that is called part of speech tagging. So the part of speech tagging is basically, we have do three things: part of speech, tagging, and corpus. So look at here, let's discuss this. Part of speech tagging means first we need to identify the tokens, then we will tag tokens to their possible meaning. Let in this case, that does, it will be tagged with a determiner. Okay, quick, it will be tagged as an adjective. Brown, it will be tagged as an adjective. Fox, it will be tagged as a noun. Jump, it will be tagged as a verb. Over, it will be tagged as a preposition. Then it will be tagged as a determiner. Lazy, it will be tagged as an adjective. Dog, it will be tagged as a noun. So first we need to tokenize it, then we have to tag it to their corresponding information. So that is called POS tagging. Okay, working of POS tagging. How? First we do tokenization to identify the words. Then we do some pre-processing to clean all the words. We will lowercase it. We will remove a special character to improve the accuracy. Then we load language model that can do the POS tagging. Okay, that is do linguistic analysis. Okay, then POS tagging will be done. So this is the basic working of POS tagging. Okay, now there are different POS tagging scheme. So one is known as rule-based tagging, another one is known as statistical tagging, and another one is known as hybrid tagging, or in some cases machine learning tagging is also there. So first one is the rule-based tagging. So what is a rule-based tagging? In basically in simple words, if we can say that, the rule-based POS tagging assigns grammatical tags using handwritten grammar rules. We have predefined rules, okay, and dictionary. Based on that, it will do the tagging. For this example, as the rule, look at the rule: assign POS tag noun to the word ending with TION or ending with MENT. So all the word which are ending with tion or ment, they will be assigned to a pos tag noun. Okay, for example, in other words, say we can say that if any another rule, we can say that if any word is ending with ing, we will assign it as a verb. Okay, so this is the rule based system. The tagged output will be, look at here, presentation, it will be noun, highlighted ed, if it is ending with ed, we will make it as a verb, so it will be verb. Okay, ent, ment, so it will be noun. So this is called rule based tagging. Okay, up to this point it is clear. Now next is transformation based tagging and statistical based tagging. So there are two more methods, and right now we are also using machine learning based tagging also. So in transformation based tagging is what? First we will try to find the, it is basically just hybrid of statistical and that uh, rule based tagging. So we will use rule based tagging to find the initial tag, then we will transform it. Now let's take an example. The tag chased the mouse, the is, it is delimiter, initial tag. Cat, it is noun. Chased, it is verb. The, it is delimiter. Mouse, it is noun. It is the initial text. Now we will rule apply. Okay, now we will transform it. Okay, so we will apply another rule. We will change chased, this chased, from verb to noun because it follows the. We have done this transformation, so we will update the tag. Now this chased will become noun. That is called transformation based tagging. Now we have this statistical tagging. So statistical tagging is basically probability or statistic based tagging. We will try to generate the probability of the tag that can be assigned. We can use here Markov model, or we can use this CRF, that is conditional random fields. Okay, how it works? Which we have to find the token, then we have to find the possibility of its having any POS tag. If the possibility is highest with the tag, we will assign that tag. That is called statistical tagging. Okay, now let's take a quick implementation to the POS tagging. Okay, now it is very easy. We have to import some libraries. We have to import NLTK. We have to import tokenizer to tokenize it. We will importing word tokenizer. Then we have to import this POS tagging, and we have to download these two. We have to download. Okay, now let's first applying POS tag. We have this text. NLTK is powerful library for natural language processing. Now at the first step, we have to tokenize it. So to tokenize it, we have already called word tokenizer. Okay, so word tokenize, we pass this text, it will generate the tokens. In words, we will be having tokens. Now we will call POS text, and that will be that all the tokens will be passed to the POS text. So it will generate the POS text. Look at the output. So PS tagging results are, so we are displaying it like this. Now first we are displaying word and then displaying the POS text. So it will display like this. NLTK, it is noun, is verb, A is determiner, powerful is JJ. Okay, then library is NN, for is IN, natural is JJ, language is NN, processing is NN. Look at here, all the codes has been already discussed. Okay, so this is how this tagging works. Okay, in implementation. Now let's look into the advantages of POS tagging or challenges of POS tagging. Advantages: text simplification, simply it improves the search, name entity recognition, it will be used. Now challenges: ambiguity. Okay, idiomatic expression, out of word vocabulary is there, out of vocabulary word will be there, domain dependency will be there. These are some challenges. Okay, now this synthetic analysis is there. The next phase is a synthetic analysis. Okay, now there is one more tagging is there also, that is called POS, that is called machine learning based tagging, where we use machine learning models to generate the text. Okay, now after that, this synthetic analysis, or we call it parsing. Okay, so what this synthetic analysis does? So synthetic analysis, in other words also called parsing, okay, is the process of analyzing the grammatical structure of a sentence. The grammatic, we used to process, or we used to analyze the grammatical structure of sentence, in which we will analyze how words are arranged, how the relationship between the words is happening, whether the sentence follows the grammar rule or not. These are something that we do. For example, let's take a sentence: the boy kicked the ball in his jeans. Now it is having two different interpretation. Okay, First interpretation, the boy was wearing jeans and he kicked the ball. And another interpretation, the boy kicked the ball which is inside his jeans. Okay, these two are this interpretation. Okay, okay. The boy play cricket. Okay, so synthetic analysis identifies everything. The boy play crickets and its corresponding roles too. It will try to check whether it is following the English structure or not. English structure is basically SVO, na? Subject, verb, object, or object structure. Okay, so it is following whether that rule or not. That will be done in synthetic analysis. Why it is very important? Basically, we have to understand the sentence meaning. It detects the grammar error. It detects or perform machine translation. It is very helpful. It is very helpful in question answering based on NLP rules, NLP models. It is very useful in processing the language or language conversion. So these are basically common things that is synthetic analysis is useful in. Now we have this semantic analysis. Okay, so this semantic analysis, in other way we can say that it focuses more on the sentence rather than word. Okay, up to this point it is clear or not? Okay, in synthetic, in this case we have to deal with the word na, so we will generate past tree here. So past tree means we will be having sentence, and from sentence we will go to generate the words, and in reverse case we have a words, then we can generate a tree like structure to from the sentence. That will be done. This, it is more like a parsing na. Now in case of this semantic analysis, so semantic analysis, it is more like a dealing with the meaning of entire sentence rather than word. Okay, so semantic analysis is process of understanding the actual meaning of word, phrases, and entire sentence. Okay, now it will try to learn the word meaning with respect to this context in the entire sentence, so that the actual meaning of the sentence can be generated. Okay, so semantic analysis basically determines what sentence actually wants to convey. What is the actual meaning of the sentence? Okay, now for example, Apple launched a new iPhone, where apples refer to the company, not the fruit. If we are simply taking a simple apple word in previous phase, then it will be having two words. Now it can be a fruit, it can be a company. But while looking the entire sentence, now we are sure that Apple is a brand rather than it is a what you can say, a fruit. Okay, now another example, let's say the cat drank milk. Okay, so cat is an animal, drank is action, milk is an object. So it is following the order SOV. Okay, so that's why it is semantic analysis is very useful, and it is used in the two key tasks in semantic analysis is name entity recognition and word sense disambiguation. Okay, now we have this discourse agreement. Now it is more like in discourse agreement, it is more broader version. So more broader version means now in discourse agreement, we will now look into the sentence, which the context of the sentence before that sentence and after the sentence. Now it will try to find the context of a sentence in its surrounding. Okay, so discourse agreement, discourse integration is basically is the process of understanding the meaning of sentence by considering the sentence that comes before it and that comes after it, so that it can generate the context of a sentence. Okay, so simple meaning, basically it connects the sentence together so that there will be a longer meaning, or there will be a more generalized information that we can predict. Okay, so we have this two key aspects of discourse integration, what is anaphora resolution and contextual references. Okay, so let's take an example. Let's say Ravi brought a new laptop. He is using it for coding. Now in this case, that he very is important. He means Ravi. If we are dealing it separately sentence wise, Ravi brought a new laptop, it is another sentence, and we are, if let's say he is saying he uses it for coding, then this he is missing. Who is he? We don't know. But when we have to understand that he uses it for coding, that sentence is related to the previous sentence, so that context can be understand. Okay, so it means we are saying it Ravi, and he uses it is basically we are saying it for laptop. Okay, so that is the basic broad thing that we do in discourse integration. Okay, up to this point it is clear. Now the next thing is a pragmatic analysis. So pragmatic analysis helps in understanding the deeper meaning behind the word sentences by looking beyond their literal meanings. Okay, While semantic analysis look at the direct meaning, it considers the speaker's and writer's intention, tone, and context of communication. In simple way, we can say that pragmatic analysis is process of understanding the intended meaning of a sentence based on a context, situation, and speaker intention. We have to consider everything. We have to now analyze the complete scenario where we have to deal with the context, we have to deal with the situation in which that sentence has been used, and the speaker intention. Okay, so in NLP, this pragmatic analysis helps find out implied meaning, okay, user intentions, emotions, and context dependent languages. So in simple, we can say that pragmatic analysis determines what the speaker actually mean, not just what the word literally says. Word is what saying, it is not the actual meaning. We have to identify the intention of the speaker, what speaker wants to say. Okay, like a request thing. Can you open the door? It is not a question, it is a request. Okay, that will be basically, it's a basically intention. So we have to we have to analyze that will be done in pragmatic analysis. Now let's go for the NLP classification task. So in NLP classification task, we have input, we have pre-processing, we have feature extraction, we have model development, then we have model assessment. Now we have to look into the feature extraction part. Okay, we have already done everything. Now we have to extract features so that model can be trained. Okay, now the feature extraction is basically what it is. We already know now what is feature extraction. What all of you know what is a feature basically. So basically, feature is some patterns or some meaningful information that can represent in a small dimensional space the entire text. Okay, so in NLP, feature extraction is the most important step because we extract feature, we train the model based on the feature. Okay, so basically, feature is what? Feature is basically, it's a meaningful information or meaningful pattern that we try to find or we try to extract from the data so that this feature can be fed into the machine learning model for its training. So feature extraction is also called text representation, text extraction, and text vectorization. So what is what is this feature extraction for the text? You already know. Okay, we have this what is feature extraction from the text? Basically, it's we have textual data. Okay, that data cannot be directly fed into the machine learning, because machine learning model don't operate on textual information. So that's why we need some kind of a mechanism or some kind of a technique to represent those texts into a numerical information. That is the feature extraction. Okay, why do we need it? Because we already know now machine learning model cannot understand the text. So we have to do or convert it to a numerical representation. That's why we need feature extraction. Why it is difficult? Okay, because in NLP there is so many ambiguity. We have already discussed. So it is very ambiguous. Okay, and so it is very difficult to extract the actual features. Now, what are the techniques? So generally we use these 6 techniques: one-hot encoding, bag of words, n-gram model, TF-IDF, custom features, and word-to-vec representation. Okay, these are called word embedding also. This we can convert word to vec and we can directly feed it to a deep learning architecture. Okay, and these 5 we can use in machine learning also. Okay, although you can apply deep learning with this also. Okay, now let's start with one by one. Okay, one-hot encoding is basically. So what is one-hot encoding? Basically, simply. So one-hot encoding, now word it is clear, one-hot encoding. It means we have to encode the entire sentence in one hot position. One hot position means for a first word, we have to represent it in a vector representation that will be having one place at 1 only. It means in only one place we can put 1 and rest all the places it will be 0. It means in entire vector representing a single word will be having only one hot position. That is 1. Okay, so one hot encoding means converting the word of your document into v-dimensional vector. This technique is very intuitive, meaning the simple, and you can code it yourself. Okay, each unique word in the vocabulary is represented with a binary vector. Okay, only one position contain 1, so that is called one hot. Okay, and all the other position will be 0. That's why we call it one hot encoding. Okay, now let's take an example. Consider the sentence, I love NLP. Okay, now create a vocabulary. I have I love NLP. I have 3 words, so the index of this word will be I love NLP. So vocabulary size is 3 in this case. Now assign binary vector. So we have 3 positions, so we need 3 vector, 3 binary position. So look at here, it is the first position. Index is 0, so 0 position is 1. So we have represented 1 0 0. So this 1 basically represents its index number. In this case, its index number is 0. It was the first position. Okay, so it has been 100. Love was in second position. Okay, in this case the index is 1 because index has been started from 0 na, but position is second in the vocabulary, okay, or dictionary. So we have written 101. In NLP, the NLP was the third or a second index and third position, so we have written 001. So it is called one hot encoding in entire vector. It is a v-dimensional vector where v will be your size of vocabulary. If the size of vocabulary is 100, then it will be 100 dimensional vector. Okay, so it is 100 for I, 101 for love, and 1001 for NLP. Okay, so when we have to represent I love NLP, then the encoded form will be for I it is 100, for love it is 010, and NLP it is 001. Now we have to represent I love NLP. Now it was separately written I love NLP. Now we have to how we can generate a numerical information from this. So that will be basically passed into a single matrix. It will we will pass this entire chunk in a single matrix. So it will becomes 100, 010, 001. It will be a 3 cross 3 matrix. Okay. Now let's take another example. So we have this corpus. We are learning natural language processing. We are learning data science. Natural language processing comes under data science. Okay. Now consider this. We are learning natural language processing, and data science comes under data science conduct. So total vocabulary size will be 10. Look at here. We are learning natural language processing. Data science comes under. So their vocabulary size will be 10. So it will be different because in this entire sentence, 3 sentence, we have 10 unique words. Our we will be having these 10 positions. Okay, the first position we. So first position we will keep 1, rest will be 0. For R, it will be second position. For learning, we will be third position. For natural, it will be fourth position. For language, it will be fifth position. For processing, it will be sixth position. For data, it will be seventh. For science, it will be eighth. Comes, it will be ninth. And under, it will be 10th position. Okay, so in this way, we can write one hot encoding. Okay, another example, cat eat fish and dog eat meat. It is our corpus. Now we have to consider these two. Okay, now let's look at the unique words. So we have total 5 unique words. Cat, eat, fish, dog, milk. Okay, so cat, eat, fish, dog, meat. So total 5 vocabulary sizes 5. Okay, so we can write it. It is first position. So at first position 1. It is second. So second position is 1. It is third. Third position is 1. It is fourth in the vocabulary index. So fourth position is 1. It is fifth in our vocabulary. So it is fifth position. So now this is the one word encoding for all the words. Now first sentence, cat, eat, fish. Okay, so cat we can put here, eat we can take this, fish we can eat this. So by keeping these 3, it will be a matrix representation. Dog eat meats, so we can get dog sentence is here, eat from here and meat from here. So dog eat meat, it will be a 3 cross 3. It will be a 3 cross 5 matrix. So look at here, these are the matrix representation. Okay, now bag of words, it is another way of generating the features. And so basically bag of words is feature extraction techniques used in NLP to convert the text into numerical form. So it represents document based on the word represented in document. Now we have to find the frequency of those words. That's why we call it a bag of words. Basic idea. Okay, suppose we have this sentence, I love NLP. So bag of word only cares about I love NLP. It do not care about the order. It don't care about order. It simply keeps I love NLP in its. Okay, now let's take an example. Now consider these 2 sentences, cat eat fish, dog eat meats. Okay, now we have sentence 1, cat eat fish, dog eat meat. Now tokenization will be done. So we have 3 tokens here, we have 3 tokens here. In our vocabulary, total tokens will be how much? 4. Cat eats fish, dog meat. Cat eat fish, dog meat. Total 5 tokens will be there, and this will be our vocabulary size. Now how bag of word? Now we have to count the frequency. Now in cat eat fish, the count of cat is 1, eat is 1, fish is 1, rest is 0. So it will form 1 1 1 0 0 0. So look at here, the cat eat fish has been now represented in a single vector. Now for second, dog eat meats. So cat is missing, eat is there, fish is there, dog is there. Sorry, fish is not there, dog is there, missing meat is there. So it will be 0 1 0 1 1. So it will be now again a 5 elemented vector. Now these 2 sentences can be put together via a matrix. That is called bag of words. This is the for first sentence, this is for second sentence. If you are using this one hot encoding, so assume that how much sentences, how much it will take. For cat it fits, it will be 3 cross 5. For dog it meets, it will be 3 cross 5. Total 6 cross 5. Now in this case, it's just a 2 cross 5 matrix. So dimension has been drastically reduced. Okay, so this is bag of what? Another example is there. Now we have 3 sentences. I like machine learning, I like deep learning, and deep learning is powerful. So now we have to identify all the tokens, unique tokens. We have I like machine learning, deep is powerful. Okay, we have arranged now same in this case. I like machine learning, so I is present. Okay, like is present, machine is present, learning is present, rest all are absent. So it is 1 1 1 1, rest 0. Okay, I like deep learning, I like is present, then deep and learning is present. So it will be 1 1 0 1 1 0 0. Look at here, deep learning is powerful, so it is deep is there, learning is there. Okay, is there, powerful is there. Okay, so basically it will be 3 zeros followed by 4 ones, and the final bag of matrix will be this combination of these 3. So this is called bag of words. Now we have this, that was, now we have this frequency based bag of words. Look at here, we have 2 bag of words. One is binary bag of words, which checks whether the word is present or not. Simply, it does nothing. If it is present, then it will mark 1. If it is absent, it is marked 0. Okay, now for example, if we are using machine and deep, so let's say machine is there and deep is absent. So for machine is present, it will write 1. It won't count the occurrence of machine. Frequency based bag of word will now count the occurrence of word. Okay, rather than putting only 0 1. Now in this case, NLP AI is there, so NLP has been occurred twice, so it will write 2. AI has been occurred 1, so it will return 1. So it will be more like a decimal version, it will be more like a binary version. Okay, now bag of n-grams. So basically, now we have already discussed that n-gram technique. So we have bigram, trigram, n-grams. So bigram, it means it's a combination of 2 words. Trigram, it is combination of 3 words, and it's combination of n words. So look at unigram, we are considering only machine. Bigram, now machine learning. Trigram, deep learning model. 4gram, natural language processing system. So now we will consider this, rather than considering a single word, now we will consider pair of words in our bag of words. Okay, now let's take an example. So process is same. Tokenize the text, generate n-grams, build the vocabulary, count the frequency of n-gram, create the feature vector. The process is very straightforward. Now let's take an example. I love machine learning is there. So first tokenize it. I love machine learning. Now generate bigram. So take pairs. So it will take I love machine, machine learning. So total 3 bigram token will be there. I love machine, machine learning. Okay. Now this is our vocabulary. Now in next step, what happens? Now vector representation, I love is 1 already present. Love machine is already present. Machine learning is already present. So vector representation will be this. This is called bag of n-grams. Okay. Now bag of n-grams, another example. Now let's take 2 sentences. I love NLP. I love machine learning. Okay. So from I love, it will generate I love NLP. From here, it will generate I love machine learning. Now bigrams will be I love NLP. I love already present. Love machine learning. So look at here. It generated I love NLP, love machine learning. Now first word, it is I love NLP. So it will be I love present. So it will be 0. Then love NLP is present. It will be, sorry, I love is present. It will be 1. It will be 1. Rest 2 will be 0. So it will be 1 1 0 0. Okay. In this case, I love machine learning. So I love is present. So it is 1. Then love machine is there. It is 1. And machine learning is there. So it will be 1 0 1 1. So look at here, 1 1 0 0. It is 1 0 1 1. Jointly, if you want to represent this tree, that the final bag of words will be the first row vector versus the second row vector. Now this will form a matrix representation. Okay, this is how bag of n-grams will be represented. Okay, now bag of n-grams, another example with the 3 trigrams. Now let's say deep learning improves accuracy. Now let's take n equals to 3. So trigrams, we have 3 trigrams. Deep learning improves accuracy. So we have these 3 trigrams. We will put it. Both are present. So the vector will be 1 1. So when n is increasing, the vector size will be decreased. Okay, that is the basic phenomena. Okay, now to find the optimal n value, it's the ablation study. You have to use different. In general NLP task, we used to keep different n values or try to extract features. Okay, now we have the most useful thing, that is TF-IDF, that is term frequency and inverse document frequency. Now, what is a term frequency and inverse document frequency? It improves on one hot encoding and bag of words. It is more better version of this. Okay, so why we do need TF-IDF? Because bag of words, frequently occurring words get higher importance. Okay, so example, the, is, are, these are getting more importance, but these are conveying least information. That is the major problem. Now TF-IDF reduces this. Okay, TF-IDF gives more weightage to those which are very unique words. That's why we use TF-IDF. Now, what is TF-IDF? The first TF is term frequency and IDF is inverse document frequency. These are a statistical measure that evaluates how relevant a word is to a document in a collection of a document. It means we have a collection of document. It means, let us assume you have a page and you have a document. It means you are having sentences. So a word, how important a word in one sentence in entire page, that is what means. Okay, it means it is, we are checking a word's importance in the entire page and its importance to a that sentence it is existing. So term frequency is what? So basically term frequency is number of times a word T has been appeared in document D divided by total number of terms in the document. So document, documents mean we are writing about one sentence, and collection of document will be your entire paragraph or entire page. Okay, so the number of times a word appears in a document is divided by the total number of words in that document. That is the term frequency. Okay, it means a term's probability in the entire word. Measure how frequently a word appears in a document. Okay, now let's take an example. Now document is AI, NLP. So total word are 3, AI is 2, NLP is 1. So TF for AI is 2 by 3 and TF for NLP will be 1 by 3. Okay, so the feature will be, the TF for this feature will be, we have 2 unique words only now, so feature will be 0.67, 0.33. This is TF. Okay, now we have to discuss the inverse document frequency, that is IDF. So this IDF measures how unique or rare words is across all the documents. It checks whether the word is unique or not. The logarithmic function, the logarithm of number of document in the corpus is divided by the number of documents where the specific term appears. Okay, the formula is log n by DFT, where n is the total number of documents that we are having and DFT is the number of document containing that term T. Okay, now let's take an example. We have these 3 documents: I love NLP, I love machine learning. Machine learning is powerful. So step 1, we have to create the vocabulary by tokenization. So I have created this dictionary as I love NLP, machine learning is powerful. These are unique words we have created. Okay, now document frequency we have to count. So we have to check I has been present in how many documents. So it is present in 2 documents. So DF will be 2, document frequency will be 2. Love, it is present in 2 documents. Look at here, 2 documents, document frequency will be 2. NLP present in 1 document only, so document frequency will be 1. Machine present in only 2 documents, so the document frequency is 2. Learning present in document 2 and 3, so frequency is 2. Is present in only D3, so 1. Powerful is present in only D3, so is 1. Total documents, how many we have? We have 3 documents, so N is 3 and these are the document frequencies. Now let's calculate the TF-IDF for NLP, IDF for NLP. So NLP, IDF, it's a log 3 by 1. It's log N by DF. Na? So look at the NLP word. NLP word, it is DF is 1. So DF1 and total number of document is 3. So it will be 3 by 1. So log 3, it will be 0.477. Look at for why? Look at here. It's high because it has been appeared just for once. Look at here, IDF for love. Love, it has been appeared in 2 documents. The document frequency was 2. So it is 3 by 2. Log 3 by 2, it is 0.176. Now, if the document is more frequent, the term is more frequent in the documents, its value of IDF will be less. If the document is, if the word is unique in the document, the value will be high. So it gives more importance to those words which are more unique and gives less importance to those words which are more frequent. So NLP gets higher importance. Why? Because it is rare. Love gets lower importance. Why? Because love is appearing in multiple documents. Now we have to calculate the TF-IDF. We have calculated TF, then IDF. Okay, now let's take 2 examples. This D1, D2, I improves healthcare, AI improves education. So step 1, we have created the vocabulary. Look at here, the vocabulary we are having. AI improves healthcare education. Now calculate the TF, term frequency. AI improves healthcare education. In first, it is 1110. So term frequency will be in this case 1 by 3, 1 by 3, 1 by 3, 0. In second word, AI improves education. In second document, the term frequency, AI appears 1, improves appears 1, education appears 1, healthcare appears 0. So it will be 1 by 3, 1 by 3, 1 by 3, 1 by 3. Now we have already this. Now let's calculate the IDF. N is 2. So we know na how AI has been. For AI, it will be 2 by 2, so 0. For IDF improves, it will be 0. IDF healthcare, it will be 2 by 1, so it will be 0.301. And IDF, because it's appear in only one document. In appears in both documents, that's why it is 2 by 2. It appears in both documents, that's why 2 by 2. Log 1 is 0. Okay. It appears in two documents, D2 only, so it will be 0.031. It is 2 by 1. Okay. So these are IDF. Now TF IDF calculated. Now what AI? TF is 1 by 3, IDF is 0, TF IDF is a multiplication of both. It is 0. Improves, it is 1 by 3, IDF is 0, it is 0. Healthcare, it is 1 by 3, it is 0.301, both multiplied, so it is 0.1. Okay, in second document, everything previously we have calculated, AI improves. Now in this case, it is education is just another word. Okay, so it is 1 by 3 and IDF is 0.301. So this will be multiplied, we will get 0.100. So these are IDF factors. This can be treated as a features. Okay, up to this point it is clear. If you are having any doubt, you can ask me. Now we have another thing that is called word to vec. Okay, so basically a word to vec is a word embedding technique that converts the words into dense numerical vectors so that words with a similar meanings have similar vector representation. Okay, now let's see how word to vec works. Look at here, we have example. Okay, words appearing in a similar context tends to have similar meaning. For example, king, queen, prince, princess. These are similar words. Na? It appears the context is the same. So these words often appear similar context. Thus, the word to vec place them closer together in a vector space. Now, look at here. If we are generating a word embedding, so it will be like in binary form. If we are generating a vector word to vec product, it will be a more like a decimal version. So in word to vec, what happens? It keeps the contextual information. If similar context are there, they will put them in a close together. Okay. Now, why word to vec is better than one hot encoding? Because vector type is in one hot encoding, it is very sparse. Only one position will be one, rest will be 0. But in case of word to vec, it is dense. Captures meaning? No, one hot encoding doesn't capture any meaning. It captures because it keeps similar context information together. Memory efficient? No. Why? It is taking large memory, it takes a smaller memory. Semantic similarity, it doesn't find, it finds. Vector size is very huge in case of word in one hot encoding, but in case of it is very small. Okay, now important concept. Look at this. If we are king, we minuses man plus woman, it will form the queen. It means if we have a king, we have a king value, something in word to vec. If we subtract the value, man's value from the king and add the woman, then the generated information will matches the queen. This is the semantic relationship that it holds. For example, in this case, let's say these are some values. Na? Let us assume that it's a value of king, it's a value of queen, okay, and it's a value of a man. So in that case, if we perform this operation, king minus man plus woman, so it means value of king, value of man, value of woman, we will do this operation, then in general, it will generate the queen. So it captures the semantic information or contextual information. That's why that word of vec is very useful. Then we have two types of word of vec, what is known as continuous bag of word, CBOW, and escape gram. So I am not explaining these two. Okay. So let's discuss quickly about the NLP case studies. So we have this major case studies in India. That project has been launched. One is TDIL program launched. It has been launched by MIT Government of India. It's a basically development of Indian language technologies. We have Angla Bharti, then developed by IIT-Dhanbad. It's English to Indian languages. Machine translation is there. This is where we have then Anusaka, that is IIIT Hyderabad product. It's a language access system for Indian language. We have Anubharti. It is IIT Kanpur product. It's a hybrid machine translation system. We have Aksharan OCR system developed by CEDAC Pune. It's a OCR for Indian scripts. We have ILCI Corpus project. It is basically JNU plus Constorium. It's a large multilingual annotated corpus. It's a basically database collection. Then we have Indian Indian language speech corpora, okay, generated by CDEC and IDIL together. It's a basically a speech data set for ASR and TTS. Then we have this text to speech TTS system generated by CDEC. It's a basically a speech synthesis from India's languages. Then we have Bhasani mission, one of the most famous mission, Bhasani mission, generated by MIT. Okay, it's a basically AI based multilingual language platform. Okay, now it's a Bhasani case study where it is literally generating so many information in multilingual information. Look at here how the features is text translation, it do text translation, it do speech to text conversion, it do text to speech conversion, it do voice to voice translation, it do transliteration, converts the script in between language. Okay, these are the things that Bhasani does. Okay, area use cases. Look, it can be used in governance, railways, healthcare, education, and digital services. So these were the real-time case studies that Indian government are funding. Okay, these all are funded by Indian governments. Okay, these projects, and these are the NLP projects that currently IIT Kanpur, IIT Hyderabad, these so many institutions are doing. Okay, now let's take another example. It's a basically one efficient sarcasm detection using linguistic feature and ensemble machine learning model. Quickly, we will see it. So we have to detect sarcasm. So how to detect sarcasm? Look at here. So we have this data, sarcastic data and non-sarcastic data. Okay, so total where we will be having normal text. Then we have these. It's a basically Indian news line headline data set. Okay, look at here, India, which contains 26,709 news headlines containing 11,734 headlines convey sarcasm and 14,985 headlines that are conveying non-sarcastic. Okay, so these are the our target was by checking news headlines, we have to classify whether the news headline is sarcastic and non-sarcastic. So how we can do it? So what we have done? So initially we have we have extracted the that all the data was in the CSV formatted. So we have do all the pre-processing where we have extracted the text data. Then we have perform word level segmentation. Then we have character sentence level segmentation and word level sentence level tokenization followed by word level tokenization. Then we have done cleaning so that we have removed all the stop words, all the punctuations, all the special symbols. We have removed it, everything. Okay, once that has been removed, then we have extracted 13 features. First, we have calculated the entropy from the entire text. Then we have calculated from lex diversity. Lex diversity basically gives you the occurrence of unique words with respect to other words. Then we have calculated DCL readability score. So DCL readability score basically gives, it will tell you how complex a sentence is, whether it's easily readable or it's more complex to read. Then we have Fletch reading score. It is also the same, whether the reading can be easy or difficult based on the sentence. Sentence is complex. It deals with the syntax complexity. We have counted the stop words. We have counted the wrong words. We have counted the difficult words. We have counted the lengthy words. Difficult words means as per the English dictionary. Okay, lengthy words, the words having length more than 2. We have calculated 2-letter word. We have counted single letter work. We have counted number of verbs, adjective, nouns in each document. Okay, or each single corpus, and we have then normalized it and joined collectively. This forms a feature. Okay, let's say one sentence is there or one headline is there. From that one headline, we have calculated this 13 feature. Once this 13 feature has been extracted, then we have passed it into a different classifier like gradient boosting classifier, decision tree classifier, random forest classifier, support vector classifier. Then we have this naive Bayes classifier, KNN classifier, and logistic regression classifier. Based on that, the top performing models. Okay, we have selected top performing NLP models, and we have done the ensemble learning. Look at here, and we have also used all the features have been fed into a dense network also. 13 nodes will be in the input layer, and we have used a dense network here. So we have done both, and in result you can see that these are the accuracy result. Here you can see that this random forest, this decision tree, and gradient boosting is literally achieving 92% accuracy with these just 13 features. It means the entire corpus will be represented with the 13-dimensional vector only. Okay, now these are the classification. When we had done ensemble learning, we have selected these 3 only, the top performing 3 models. Then we have extracted with majority voting, ensemble averaging, and we have done the dense network we have used. And look at here, dense network, it's a deep learning model. It is performing poorly as compared to the ensemble models. Okay, these are some other results. So this was another case study. So I think we can stop there, and from next class we will start from this AI project life cycle.
Thank you,
Okay.
sir.
Okay. That AI life cycle is most theoretical. It is a basically theoretical concept. We will discuss it in next class with an example. We will take a real life example and we will do AI life cycle.
Thank you, sir.
Okay. If you have any doubt, you can reach me out. I will share this PPT with all of you.
Thank you, sir.
Okay.
Thank you very much, sir, for a very extended session. And thanks all the participants for your patience and active participation. Good night, everyone. Good night, sir.
Okay. Thank you, sir. Good night, everyone. We will meet in the next session.
Thank you, sir. Thank you.
Thank you.